respected faculty, invited guests, and all those who have joined us today. I, Charu Singh, on behalf of the organizing team, welcome you all to the fifth preliminary session of the 5 days faculty development program on building a sustainable future with green technology, innovations, opportunities, and challenges organized by the Amity Academic Staff College in association with Natural Resources and Environmental Science domain. The theme of the session is Combating Technological Challenges to Decode a Green Tomorrow. In order to decode a green tomorrow, we must confront various technological challenges that hinder our transition towards sustainability. While renewable sources such as solar, wind, and hydro hold immense potential, we need to enhance their efficiency and cost effectiveness to make them viable alternatives to fossil fuels. Additionally, energy efficiency technologies play a crucial role in reducing our overall energy consumption. Advancements in smart grids, energy efficient appliances, and intelligent transportation system can help or optimize energy usage and minimize waste. Technologies like recycling, upcycling, and waste to energy conservation are instrumental in achieving a sustainable future. Lastly, the development of smart cities powered by LOT devices and data-driven decision-making can optimize resource allocation, improve urban planning, and enhance the overall quality of life. And in today's session, we are going to explore this innovative technology. So it's a great privilege for us to welcome the first speaker of today's session, Dr. Gaurav Govardhan. He is a scientist in Indian Institute of Tropical Meteorology. His research interests are aerosol climate interactions, model simulations of aerosol, model evaluation and improvements, mixing state of aerosol, effective radiative forcing, cloud radiative forcing, air quality and modeling, and air quality management. He has completed his PhD from Center for Atmospheric and Ocean Sciences from Indian Institute of Science in 2018. He has received many awards in 2018 for postdoctoral fellowship at Atmospheric and Oceanic Sciences, Princeton University from 2010 to 2017, Jeremy Grantham Fellowship, and scholarship from Ministry of Human Resource and Development, Government of India, Indian Institute of Science. Sir, today we are honored to have you with us, and before we moved ahead, as a part of Amity University tradition, we would like to facilitate you with a virtual Tulsi sapling as a symbol of love, respect, and gratitude. Sir, I request you to kindly accept it. Thank you, sir. Over to you.
Thank you. Thank you. Can you all hear me now?
Yes, sir. You are audible.
Okay. Okay. Let me. Should I start the talk now?
Yes, sir. You can start.
I'll start sharing my screen. Can you all see this? Okay, can you see my screen?
Yes, sir.
Yes, sir.
It's visible.
Okay, wonderful. First of all, I thank you for this kind invitation and kind introduction of me. It's really honored to be part of this wonderful FDP program. And I mean, it kind of gives us also some sort of exposure to what's happening in the Amity University and what are the faculties there up to, and also having some interactions with faculties and other staff as well as students at the Amity University. So it's going to be a very interesting interactive session, I suppose. So today I'm going to talk about, I would say, two things. One is about a state of the science air quality forecasting system, and second is kind of a sibling of that, which is we call as decision support system. These two systems essentially put into one become very useful in a sustainable world, and how is something I'm going to explain through this talk. So this particular graphic suggests us that basically we are looking at air quality forecasting. Our center IITM looks at air quality forecasting uh, over entire India, and the focus right now is on our national capital, New Delhi. And one doesn't have to explain why the focus is on New Delhi. Uh, but if you see, when air quality in New Delhi is concerned, it is it's a it's a result of what is happening in the vicinity of New Delhi, just in the New Delhi during winters, while in summers it is a result of what is happening in far distant locations. Maybe what is happening in Punjab, Haryana, sometimes what is happening in arid regions of Arabia. So, if one wants to look at the air quality and wants to forecast air quality over New Delhi, one has to design a system which is capable of resolving and identifying, mimicking all these processes, the processes that are happening in the vicinity of Delhi and the processes which are happening little distant from Delhi. And today I'll be explaining our air quality forecasting system, which nicely captures that. And also on top of that, we have designed a decision support system, which has been very useful for the policymakers. So very quickly, hang on. Okay, okay. This is the air quality early warning system, as we call as this air quality forecasting system. We have named it as air quality early warning system (AQEWS). This gives you forecasts for entire India for every day for next 3 days. So for every location in India, I get air quality forecast for next 3 days, and this is happening at every 10-kilometer grid point. That is, every 10-kilometer location in India now has a air quality forecast for next 3 days. And the uniqueness of this particular system is that it talks to observations all the time, because it is not a standalone computerized model. It talks to observations. It talks to satellite data in terms of taking the farm fires or stubble burning information. It talks to another satellite data for aerosol information. It also talks to surface measurements of PM2.5 or PM10. I hope PM2.5 and PM10 is particulate matter with a effective radius less than 2.5, less than 10 microns, respectively. So these measurements of particulate matter are carried out at more than 260 sites over India, uh, mainly organized by CPCB. And these particular measurements also go in this forecast. Apart from that, very key part of this forecast is its ability to zoom in as far as Delhi is concerned. So from this 10-kilometer horizontal resolution over India, we zoom into first 2 kilometers over NCR and over 400 meters over Delhi. So every 400-meter point in Delhi essentially has distinct air quality forecasting information through this system. And for that, we are putting in very high resolution emissions inventory. And for Delhi, we are also putting in data. We are also assimilating data. In a way, we are talking to observations every day in the model, which are 43 in numbers. So there are 43 stations of CPCB, DPCC across Delhi. We are incorporating those stations into our modeling systems to give forecast for the next 72 hours. So this is the overall broad, simplest overview of this system. One would want to know how this communication with the observation improves this forecast, because as I said, uh, the main uniqueness of this forecasting system is its communication with the observation. So here I show you that when we are incorporating satellite retrieved aerosol information, that is particulate pollutants information, and the information here is named termed as aerosol optical depth, which is like from surface to entire top of the atmosphere information about aerosol loading. When we incorporate this information in the model, what happens to model forecast? So here you can see this is model forecast without this information from satellite. So this is the aerosol optical depth in the model, and you can see this is close to 0.4, 0.1 values. This is the actual values. These are actual values of these parameter. These are model simulated values, and these are model simulations when you put in the aerosol optical depth from observation. So upon incorporating observational data through a very state of the science system, we get high improvements, large improvements in aerosol optical depth in the model. Corresponding improvements in near surface particulate matter pollutant PM 2.5 are also seen. Here, this is my model version without satellite information of aerosol optical depth. This is my model version with the satellite information, and these are observations. So you can see considerably model shows improvement in PM 2.5 upon discussion with satellite data. Same thing can be seen on daily mean. These are hourly means, these are daily means. The second communication that the system has with the satellite data is in terms of fire count. Now, you all know that sitting in Delhi, especially during the post-monsoon, that is September to November part, the stubble burning or parali burning issue is very severe, especially in the parts of Punjab and Haryana. So every day, whatever number of burning events that are happening, they are with certain uncertainty are captured by satellite data sets in terms of fire count information. This fire count information is very vital for a model in terms of simulating the PM 2.5 values at the surface and simulating the air quality. This information is communicated to the model through our utility, and this is again one uniqueness of this system. And upon communicating this particular information into the model, what we see is this. You can see here observations of measurements of PM 2.5 are shown in black color here, and the blue color shows the model simulations without this information from fire count, while red color shows model simulations with the information from fire count. So you see how vital are the fire counts information for the model forecast. And thankfully we are doing this, which is making our system very accurate. So when you do similar things, even for surface measurements, I just showed you that we have more than 260 sites and more than 43 sites over India, over Delhi, in which PM 2.5 mass is measured, and we incorporate that into model, and we see how close do we get to the actual observations upon modifying this. So this is again without assimilation. Assimilation is interacting with observations or communication with observations, and green is with assimilation, and blue is the actual observation. So you see how close do we get to observations upon this. So when you run all this system and when you forecast for a city like Delhi, one is interested in understanding what is the accuracy of the forecast, and what is the accuracy of the forecast for first day of the forecast, for the second day of the forecast, and for the third day of the forecast. So here I show certain numbers which tell us that when air quality is in very poor conditions, or when it is in severe conditions, when air quality index is in beyond 300 and beyond 400, you see that the normalized mean fractional biases in the model on day 1, day 2, day 3 are within the limit. Fractional biases, fractional errors, this is happening at 10 kilometers resolution, but even at 400-meter resolution, you see they are well within the limits for all the entire 3 days of the forecast. And especially when very poor, even in severe conditions, you are still within limit, which makes this system very important for in general giving idea about what's going to happen in future, and helping the policymakers. Same way, if you see what is happening to the accuracy or false alarm ratios. False alarm rates is you predict something and that particular event does not happen. That particular probability is very low for our system. So most of the times it does not give you false alarms, which is very important. And the accuracies are, you see, for unhealthy, very unhealthy, you see these are very high numbers. So this is probably one of the most accurate air quality forecasting system in the world, uh, which is focused on a particular city. So this is something very interesting about this. If you just do a little more evaluation of the system, here I show probability of detection and frequency of hits. Just don't go into details of what's exactly these numbers mean. But if one wants to see from this figure, then an ideal model would actually sit at the top right corner here, and our model is approaching to that value. Of course, there are certain issues that we are still sitting here, but under certain conditions we have reached there, and the next task for us is to take a jump from this particular points to these particular points. So this is something we are now aiming. So how did this system perform in the recent winter of 2022-23? Here we show the measurements of air quality index averaged over Delhi during this particular season, and the blue line shows the forecasted air quality index. And you see how closely our model matches with the observations. Yes, there are certain hiccups around, but more or less it quite well captures the tendencies, the reductions, and the sharp increments. All these things are quite well captured by the model. Just for our exercise, what we did is we took multiple international, national uh, air quality forecasting models, looked at their performances over Delhi, and compared with our model, that is air quality forecasting model. Can you all hear me?
Yes, sir. You are audible clearly.
Okay. So what we can see here is our model shows the least root mean square error in terms of comparison with observations, the highest index of agreement, the least mean biases, and least normalized mean error. So as far as Delhi is concerned, certainly our model is doing the best as far as air quality forecasting is concerned. But we know that we are still away from the observations, and that is something that we want to achieve in the next season. But air quality forecasting is one thing, and it tells you, okay, event is happening, and we need to work on something on that, and we need to do some sort of interventions to to reduce exposure of the population. So this in some sense it's very important tool in a sustainable world for policymakers. But policymakers need some more information. They want to know what is going to happen in terms of when the event is going to occur, which sources are going to be responsible for the events. For example, in Delhi, the event is happening, air quality, extreme air pollution is going to occur. Then where is the pollution coming from? Which sources are going to be responsible for that pollution? And how can I control that pollution or those sources so that I will hopefully avoid the forecasted event. So policymakers need this information also. And with this motivation, we decided to advance our air quality early warning system into a decision support system. So decision support system, what actually it does is it actually takes in the emissions from the anthropogenic emissions from the Terry inventory, the institute in Delhi, and it gives you emissions for all these districts within NCR, and it can tell you what is the contribution from any of these districts to pollution load in Delhi. So I'm using a tracer approach for this. I of course would not want to get into the details of tracer approach here, but in all, what I would want to tell you in short is through decision support system, you can get to know what is the contribution of these 19 different districts to the air pollution that is happening in Delhi. First, within Delhi, what is the contribution that is coming from transport vehicle emissions in Delhi, industries in and around Delhi, waste burning happening in Delhi, domestic pollution happening in Delhi, construction activities, road dust, all these things, how much are they contributing? Plus, what is the contribution coming from stubble burning activities that are happening mainly in Punjab, Haryana to air pollution load in Delhi? And on top of that, this system also tells you what is the likeliest improvement that you can achieve if you reduce all these emissions by 20% or by 40%. So what are the likeliest improvement that you can get? So all this information is now available through one single model simulation. And that is the beauty of this. You don't have to do multiple simulations to get this information. You just have to run one simulation to get this information. So this is the overall block diagram of decision support system. I certainly would not go into this block diagram, but this is very similar to our air quality early warning systems block diagram, which I showed you just now. And the decision support system mainly gives you source apportionment of PM 2.5 in Delhi. It also tells you emission reduction scenarios. So all these informations are given to the policymakers for their use. As far as decision support systems performance is concerned, we can see that it is somewhere here right now, and we want to reach to this particular level. And we for October, November, for December to February, it has gone to this particular region. And as I told you, we would want to reach to this. So performance is something that we want to improve on, but this is certainly encouraging right now. So if you consider through decision support system, if you want to know through DSS that what happened to air quality in Delhi during the recent winter, then this is the result of it. From October 19th to December 26th, the Delhi's air quality or Delhi's air pollution was on a mean basis was 30% driven by Delhi itself, 25% driven by the exact bordering districts of Delhi, around 5 to 7% by stubble burning activities. You see, stubble burning activities, they are not continuous. These are pulse of emissions which are happening roughly from mid of October to mid of November. These activities roughly occur for 1 month and they contribute significantly during that 1 month. But over the entire season, their contribution is relatively small. And then there are other regions which are also responsible for other regions of NCR, of not NCR, but other states which are not falling in the 19 districts of NCR. They are also responsible for pollution load in Delhi. So roughly 30, 30, 30, I would put. Within Delhi, if you want to see within Delhi, which of the sources contributed the most, then you would understand it was transport sector which contributed 48% to Delhi's own contribution. So if Delhi is contributing 30% overall, in that 30%, around 15% is contributed by Delhi's transport sector, the vehicles. The next major contributor is the industries which are surrounding Delhi. And then the remaining contributors are residential sectors and energy sectors and construction sectors and things like that. But the major contributor as far as Delhi itself is concerned right now looks to be vehicles. As far as neighboring districts are concerned, I just told you that bordering districts also contribute to air pollution load. So as far as they are concerned, you would realize that a major portion of that comes from Jhajjar, because you have winds coming from west part of Delhi, so they carry the pollution which is happening in Jhajjar to Delhi. So Jhajjar is contributing, non-negligibly. Then you have contributions coming from Sonipat, you have contributions coming from Rohtak, and then all the bordering districts. But Jhajjar looks to be the dominant region in the here. How can one use this particular decision support system in avoiding certain air pollution event? An excellent example of this is shown here. So you see, this particular event occurred in November month of 2021, just after Diwali. I will show you this particular black line here is the model forecast, and the model had forecasted around on 17th of November we are going to have a major, from 14th to 17th we are going to have a major air pollution event, and that could reach air quality index to very high value. We reported this to the Delhi government as well as CAQM, and then on the basis of our decision support system, on the basis of our air quality early warning system, both of them came up with certain restrictions. By they encouraged people to work from home, thus reducing the vehicular transport. They encouraged they decided to stop heavy vehicles entering into Delhi. They decided to stop construction activities in Delhi. They decided to sprinkle on the roads. All those interventions they started to put in, and as a result of that, we saw that actually on that particular 17th and 16th, 17th November, we avoided that air pollution event. Through these interventions, we actually made the air pollution event, less severe. And this is one of the right example of showing how this system can be used in a sustainable manner. Meaning, you still have your developmental activities going on, but as and when you see that there is some air pollution event which is going to happen, let us restrain, let us control, let us first of all understand the sources and then stop them for some time. Let the event, let it get settled down for a bit, and then we can again resume. So this is how this system could be used in an operational forecasting basis, and we showed that upon these interventions actually reduced the PM 2.5 and PM 10 by around 20 to 23%, and air quality index was reduced by 20%, and this is very substantial, especially when you have severe air pollution events. So this is an example of how this system could be used in a sustainable world. Another usage of this system is to understand how important is this implementation and revocation of GRAP, and how effective is that as far as Delhi's air pollution is concerned. So this is a schedule of GRAP which was followed during October to December 2012. And using decision support system, we wanted to understand how implementation and revocation of GRAP helped Delhi's air quality. So I'm just showing you one example during this time when stage 4 of GRAP was used, and I'm going to show you how important was to implement this stage 4 of GRAP and how effective was that in controlling Delhi's pollution. So here I show you uh, model simulations and observed air quality index values. So black line here shows you observed air quality index values, and these three different lines here show you what would have been the air quality index if there was no stage 2 of GRAP implemented, stage 3 of GRAP implemented, and stage 4 of GRAP implemented. So here you can clearly see if stage 2 was not in place, you would have received slightly high values of air quality index, even for same for stage 3. But if stage 4 of GRAP was not operational during this time, you would have seen tremendously high values of air quality index compared to what we are seeing, what we witnessed during that time. So change in air quality index just because of implementation of stage 4 of GRAP actually was 60 units of air quality index, uh, and which is roughly 10 to 20% or around 10% of that. So that's a very significant number. And because of that, we could actually manage, I mean, we could, of course, 500 AQI is not still very encouraging, but we stopped it from reaching to more than 560, 570. I guess that credit goes to the policymakers for making right calls at right time. And I hope the decision support systems information inputs went into their decision. So this is how one can use the DSS in a sustainable world. Another way of using decision support system as a tool in a sustainable world is through this sort of an exercise. So what we did is, again, this was the requirement from Commission for Air Quality Management. I'm sure all of you would be aware of this particular commission, which is recently formed, which takes care of air quality in Delhi NCR. So what they wanted to know is, what if we reduce on stubble burning and redistribute the stubble to industries, coal-based industries, and use them for heating purposes? So we did that in the decision support system. We changed those emissions in our modeling framework, and we devised two or three different scenarios of those distributions, and we found that yes, if you redistribute stubble into different industries, you are indeed going to reduce on air quality index. You are going to reduce it substantially, and that's going to be very important, important step which you could take in future. So again, you are not purely stopping stubble from getting generated, but you are using it for some other purpose. So again, making it sustainable. So this particular input, which shows that if you reduce stubble from burning and putting into industries, will certainly improve air quality in Delhi, was taken into consideration in the recent policy which was formed by CAQM, and which suggests that stubble must be reused in industries. So this sort of information is very useful for policymakers in hopefully designing the policies uh, for future. So this is it. This is now till what we have reached right now, and we have a very I would not say ambitious, but realizable future plan in which we want to increase the scope of this system. Basically, till now we have been giving decision support system information just for Delhi. Now we want to give same information for all these bordering districts, because what we understand from policymakers is that they also want to understand what is the source of pollution for Jajjar, for Ghaziabad, for Gautam Budh Nagar, Faridabad, Gurgaon, all these districts, where is the pollution coming from, and how can we control pollution not just in Delhi but in all the districts of NCR. So next phase of the BSS, which is going to come get operational very soon, we are going to track pollution and tell the information about source apportionment of all these districts. So this is what the next phase is going to be, and we are going to extend this to to make it more sustainable for not just Delhi but for entire NCR. So with this, I would like to stop the presentation and take up the questions if there are any. Thank you. Can you all hear me?
Yes, sir. Thank you, sir.
Yeah. Any questions? Hello.
Hello.
Yeah, are there any questions from the participants, ma'am?
No, sir, I don't think so. There are any questions.
Okay.
Okay, sir, actually, we missed the virtual Krusi sapling slide, so I kindly request my team to present the sapling slide.
Okay. Thank you.
Thank you, sir.
Thank you.
Thank you for your valuable time and much enlightening session, sir. Moving on, it's our honor to introduce our second speaker of the session, Dr. Vaneet Jishtu. Dr. Jishtu is a scientist with the Himalayan Forest Research Institute, Shimla, Himachal Pradesh, under the Indian Council of Forestry Research and Education of MOEFs-NCC, Government of India. He has handled more than 30 projects consultancies as principal investigator. Important ones include the ecological survey in the Hemis High Altitude National Park, Ladakh, surveys to map the Ashtavarga group of medicinal and aromatic plants, long-term monitoring global warming projects in the high altitude transition zone across Himachal, mapping of forest generating resources. Significant contribution pertains to the establishment of Western Himalayan temperate near Shimla, a novel native tree species conservation program in the Northwest Himalayas. He has a FAO fellow to study cold desert afforestation program with the USDA committee. Besides, a review member of the Cumulative Environmental Impact Assessment Committee of the Government of Himachal Pradesh. For river valley projects in the state, handled a number of consultancies and environmental impact assessment studies, notable being the EIA for the Doklam Border Road in East Sikkim. He has more than 130 publications, which include books, book chapters, research papers, research articles, as resource person on radio and television. He is the recipient of the Brandeis Award in Indian Forester and has featured among the 50 people to know across the Himalaya for working tirelessly and bringing changes in the respective fields. Rotary Shreyas Award 2022-2023 that celebrates the commemorates the achievements of individuals who have done exceptional and exemplary work in the field of their expertise. Sir, today we are honored to have you with us, and before we moved ahead, as part of Amity University tradition, we would like to facilitate you with virtual Tulsi sapling as a symbol of love, respect, and gratitude. Sir, I request you to kindly accept it. Thank you, sir. Thank you, sir. Over to you.
Am I audible, please?
Yes, sir, you are audible.
Okay. Okay, a very good morning to one and all. At the onset, I heartily acknowledge the organizers, especially Dr. Renu Duppa, for providing me such a great platform to share and advertise my dream project. Personally, a project close to my heart, the Western Himalayan Temperate Arboretum near Simla, a novel native species conservation program. I'll just start, share my presentation first. Is my presentation?
Yes, sir, it is visible.
Okay, it's visible. Okay, like I said, I'm Dr. Vaneet Jistu, working as a field botanist with the Himalayan Forest Research Institute, one of the umbrella institute under the Indian Council of Forest Research and Education, under the MOEF and CC. Well, our role is here at the institute is to cater to the research needs in the Ladakh, Jammu and Kashmir and Himachal Pradesh. And my experience is I've been working in the high Himalayas and the trans-Himalayan cold deserts of Ladakh and Spiti for over 25 years now. And the title is the Nature, Role and Value of the Western Himalayan Temperate Arboretum as a green space for Simla, as an urban green space for Simla. It's my concept of green technology that is aided and provided by nature. Well, if you see, the urban green space is what I would like to say. My focus would be the Simla urban landscape. And green space, just a minute. And the green space is very essential, actually for the good health of citizens. They're basically open spaces areas reserved for parks and other green spaces. And if we have water, we refer to as blue spaces. Then some similar sort of other natural environment. If these two photographs I'm showing you, the present one is the only green space now left in Simla is the one which is a reserved forest, and the other is the green spaces which were once developed by the British. They're the only ones, very few green spaces now left in the city. Actually, green space is, like I said, is very good for health of the citizens. In many cities, we don't have enough of it, or if we have, it is in the wrong place. You can just relate it to, like, we all enjoy a walk in the park, a street lined with trees or a view of trees from our window. But for those of us who are urban dwellers, we may not experience as much of this as we should. And besides the health benefits, these green spaces also contribute to climate mitigation by reducing the urban heat island effects, as it contributes relatively little to carbon sequestration, as cities account for only a small percentage of land use, and carbon dioxide emissions and other emissions are very high here. Also, the quality of green space is also very important. Now, if I come to Simla again, I'm showing two green spaces which were developed by the British. One is the Institute of Advanced Studies and the Raj Bhavan. They're the only good green spaces which one could consider in Simla. And with green spaces, it is also, you have your nature nearby, and which is very important because being connected to nature, even unconsciously, can make life healthy. But if there was a study recently in Europe, which says that cities in Europe could prevent up to 43,000 deaths each year if they had achieved the WHO recommendations on access to green space. Now, what exactly is the WHO recommendations? It recommends universal access to green space. It says that there should be a green space measuring at least 0.5 hectare at a linear distance of no more than 300 meters from every home, which is a far cry which we see in most cities. Then we have the global goals. We have the Sustainable Development Goals. And if you see Goal 11, it clearly states that we need to have sustainable cities and communities. And besides this SDG 2 also is connected to, the similar, the arboretum or the vegetation or the conservation of biodiversity. Now, this 11 goals aims to make cities, towns inclusive, safe, resilient, and sustainable. For that, we all need all partners to make this a success. Now, the problem today is the population is, it's just increasing, and the resources we have limited and they're receding. So the world is urbanizing at an unprecedented rate. Over half of the world's population lives in cities. This is even higher in developed countries where nearly 3/4 of people live in cities. And globally, this urbanized population is projected to increase up to 66% by 2050, with 95% of urban expansion expected to occur in the developing world. Now, coming to Simla, if you see the urbanization of Simla, not only the main town, even the outskirts now, they are being done not in a very systematic manner. To add to this is the traffic, which is not only of the local, but of the number of tourists which visit the town on a daily basis. I show this slide and I always put it as the horrors of progress. Simla today is an unplanned, haphazard urban sprawl with a population of almost over 3 lakhs, with an additional 20 to 25,000 tourists descending on the town daily during the peak summer seasons and weekends. If in a poetic way, a poet would put it, he would say that the art of a man that coexisted happily with the art of nature has now become a contradiction of the latter. Simla is a prime example of wanton degradation caused by the wheels of progress. If you see these two slides, if you see this almost less than a century ago, the forest cover was, just pretty good. But if you see today the red spots, you can see how much urbanization has come in Simla. So we need efforts to save Simla. We need to develop urban forestry and green areas. There have been a initiative with 17 green belts identified, but not much has been done in this. And to put it here, I'd just like to say that further urbanization plans at the cost of the existing cover would be extremely disastrous, and retrograde steps and must at all costs be banned totally with political will and administrative interventions. So in 2015, we had the smart city concept across the country, where one out of the 30 urban centers, the Simla was also one of them. There were 53 projects proposed with a cost of almost 2905 crores, which was supposed to be done by 2022, but we are already in 23. And what we see on the ground is not what a smart city would normally desire. We don't see any green spaces added. There are no parking lots coming to decongest the town. So the aim, which was transferring the over 200-year-old hill town into a world-class modern urban paradise, personally, I believe that this concept sounds utterly unrealistic and highly impractical under present conditions. What all so far has been done is concrete and steel has been added in great numbers to sidewalks and retaining walls, and that is all we see till now. Now, the challenges are many. If you see, there's congestion and shortage of parking spaces. There's problem in water distribution. The door-to-door garbage collection is a big challenge due to the landscape. Then there's always a threat of a major earthquake around the corner. Then inaccessibility to most of the places due to the geography and the old building stocks and infrastructure. So they all are a big challenge for the planners. However, the conservation approach should be in terms of an inclusive development plan, which aims at a sustainable future by keeping intact the values of the past, the rich values of the past of Simla. Now I come back to the presentation. I give a little background. See, we have the 2030 Sustainable Development Agenda and the associated goals. which was succeeded due to the Millennium Development Goals, which could not be, adhered to by most of the countries. So this 2030 SDG forms a very important part for the planet. It demonstrates the fundamental importance of plants for the planet, and importantly, it says that if plant conservation is not achieved, then the achievement of these goals is put at risk. It suggests that the integration and mainstreaming of biodiversity conservation and plant protection in particular are of fundamental importance to the achievement of these goals for the planet. The presentation highlights the contribution that plant conservation can make to achieve the Sustainable Development Goals. Now, coming to these goals and the role of plant conservation. The SDGs with 17 goals and 169 targets recognize the interrelation between human development and the environmental, economic, social, and political context in which it occurs. The SDGs are expected to shape the actions taken by governments in the future. Target 2.5 is a crucial entry point for botanical gardens and arboreta to contribute to these goals through their ex situ collections. The possible plant conservation actions toward SDG 2 include to complete a review of the status of ex situ plant collections and the distribution of seed banks around the world. Further research on the conservation of genetic diversity of species, linking plant conservation, agriculture, and forestry. And to work towards the achievement of global strategy for plant conservation, the GSPC we call it, especially targets 8 and 9. Now, what is this GSPC? The Global Strategy for Plant Conservation is a cross-cutting program of the CBD with 16 global targets aimed to halt the continuing loss of plant diversity and to secure a positive, sustainable future. It provides a framework for all to work together at all levels to understand, conserve, and use sustainably the world's immense wealth of plant diversity while promoting awareness at the same time. The 16 targets adopted at the global level provide guidance for setting national plant conservation targets. Now, if we come to target 8, it says at least 75% of certain plant species in ex situ collections, preferably in the country of origin, and at least 20% available for recovery and restoration programs. Target 7 and 8 both aim at species level conservation, while target 9 addresses the conservation of plant genetic diversity. The GSPC is also relevant to a number of other international agreements like the UNFCCC and the United Nations Convention to Combat Desertification. And any action we take towards achieving targets of GSPC provides opportunities for developing synergies with other international regional agreements. Now we come to the ex situ conservation part, where the botanical gardens and arboreta have a role to play. The ex situ conservation of plant diversity is addressed through GSPC targets 8 and 9. The botanical gardens and arboreta are the main institutions involved in ex situ conservation of wild plant diversity, and many have adopted target 8 either at an individual institution level or as a national network target. The botanical garden and arboreta are also active in most of other targets of the GSPs. Now, when you come to the region, the Northwest Himalayan region, due to its unique, I would say, altitude variation from 300 meters, which goes up to 600 meters, we get a lot of land, different types of climates, subtropical to subtemperate, temperate, moist temperate, and up to the alpines. As a result, it is botanically unique region which sustains unique flora and diverse habitats from subtropical to the high arid mountains. And the region which I have highlighted is the one which the arboretum at similar targets. Due to this altitude variation, we have 8 type groups of the forest with 39 forest types, with 40% being Himalayan moist temperate forests. Now, the region is also home to unique biodiversity. You can find very rare birds like the western tragopan, the snow leopard, the ibex, and a large number of threatened plant species, which are endemic to the region. The region is also a major supplier of numerous crude drugs in trade. Recent, All India Coordinated Project in 2017 came out with a report which stated that 242 plant species are recorded in high annual trade, of which 114 species are from the forest, almost 50%. And the Himalayan forest alone accounts for 36 of them. And here we have, very important plants like the Dactylorhiza, the Humes, the Arnibias, the Picrorhiza, the Gentianas, all of them are threatened genera of the region. And most of them, like I said, are endangered or critically endangered. Then coming to the location of this arboretum, it is, like say, in the northwest part of the country. It is very close to the capital town of Simla. We have the Indian Institute of Advanced Studies nearby, the famous Chadwick Falls. So they're all tourist destinations nearby. And as well as we have the State University just adjacent to the developing arboretum, where the students from the biosciences come regularly for their practicals. Now, how did this concept come into being? It came, the environmental management plans of the hydroelectric projects provides a provision of ex situ conservation for recovery and rehabilitation of threatened species and the reintroduction into the natural habitats. So the wildlife wing of the State Forest Department, upon diversion of some forest land due to the Parvati Stage 2 hydroelectric project, had stipulated both in situ and ex situ conservation projects in consultation with the Wildlife Institute of India. So as an ex situ component of the project, it included exploring prospects for setting up a temperate arboretum botanical garden, which is now known as the Western Himalayan Temperate Arboretum, for display, education, and propagation of native plants, including lesser known tree species, and their subsequent reintroduction into the wild. Now, the need and significance in the region. Well, if you see, there are presently around 122 botanical gardens in India, and most of them are in the tropical and subtropical regions. And if you see, mostly made by started by the British. In the region where we come from, we have non-existent ex situ plant conservation facilities. We have a little small, like in the UHF Noni has a small one, and the Krishi Vishwadhyaya in Palampur, or the Manali, or the Punjab University and the University of Forestry. Or as such, not very elaborate and ones are here. So this arboretum will serve as an important center of germplasm collection from the region and facilitate promoting conservation and education among all sections of society. And moreover, more importantly, it will serve as an aesthetic value, a green space, a green lungs to the people of urban Simla, besides educating them through a network of activities like nature trail, theme gardens, and nature talks. The objectives are to establish a living repository of the native Northwest Himalayan, Western Himalayan native flora, establish facility for ex situ conservation of the rare, endangered, and threatened plant taxa, including the lesser known tree species, to promote conservation education, to exchange plant propagules within the region and also outside, research, recreation, and aesthetics, creation of a very important database, and to establish international and national affiliation for further research and curation. Well, the major highs are we have taken flora semblances of Collet as a base, the baseline, which has around 128 trees, but we have somehow included some from Uttarakhand and Jammu and Kashmir, so we'll be targeting 150 tree species into different blocks of like Acer, Gymnosperm, Juglans, Rosaceae, Rhododendron, Taxus. We have different blocks. We have threatened medicine plants. We have terrestrial orchids, almost 22 of the 39 available in Simla. We have a bambusitum for native hill bamboos, fern section, and a shrubbery. It is still in infancy stage, just you could say a decade old, because most of the arboretum you see across the world are more than a century old institutions. So this one is in an infancy stage, and if advertised and Given good funding, this in the years to come would be a very important destination, not only in India, for Indians, for the country people, but also for international. We have a dedicated gymnosperm block. Then we have some very rare and endemic plants from the region, like the parrocias, the Engelhardiata, the eugenias, the Siberian crabapple, and the silverberry, and as well as the highly endemic Pittosporum. The gymnosperm block has all the gymnosperms of the region in one place. Besides, we have a small section for the students where we have kept, the British, which gymnosperms introduced by the British, like the thujas, the cryptomerias, the podocarpus, agathis, ginkgo, and the cupresses. We have a dedicated Quercus group. We have all the Quercus from the region with us, like the Quercus glauca, the Leucotrichophora, the Floribunda, the Semicarpifolia, and the Quercus bellu. Then we have the Acer group. We have all the Acers of the region with us, and notable being the Acer pentapomicum, which is highly endemic to the Kinnaur region. And among them, Acer caesium is a critically endangered by IUCN. We have some lesser known tree species which are very difficult to encounter in the forest. So it's an advantage for people who are doing research on these species to come into the arboretum, and in one place you get all the lesser known tree species in its compound. Now the region has Himachal has only 2 species of hill bamboo, whereas Uttarakhand has 4. So we have all the hill bamboo germplasm from the region, the Drepanus stachym falcatum, the Himalayic Alamus falconeri, Thamnocalamus spathiflorus, and the Eugenia ensips. Besides, when the British came, they had brought with them the Villisticus aurea, which is now over 150 years old in the town in Simla. So we have included that also in this because we are targeting only native species. So we are trying to keep away the exotics. Now, the temperate shrubbery is of recent activity in the arboretum after we are done with the trees. Now we are concentrating on the temperate shrubs of the region. So we have a good collection of shrubs. Now we have the genus Rubus, Lonicera, Buddleia, Rosa, Clematis, Jasminum, Viburnum, Berberis, Alegnus, Rives, Principia, Vitis, and a very rare Staphylia. The native shrubbery section is it's a treat to the eyes, and in the coming years we have planned to develop it further. Then we have a threatened plants, medicinal plant section, where we have most of the threatened species from the high altitude Himalayas in our collections. We have the entire Ashtavarga group with us, which is a very important group of medicine plants from the Himalaya. Most of the species of the Ashtavarga are almost, they have almost vanished from the natural habitats. Especially if you see the Shirkakoli, the Lilium polyphyllum. Collett says it was very common under Deodar forest in Simla when he wrote it around 100 years ago. But today, not a single plant of this Lilium you can encounter in the forest in Simla. Then we have the Aconitum group. There are 4 aconites in the state: the Aconitum dinurism, the Violatium, the Leve, and the Heterophyllum. So 2 of them are critically endangered, the dinurism and the Heterophyllum. Violatium is vulnerable, whereas Leve, we do not have enough data to evaluate it because it's very rare to come across in nature. But we have this in a greenhouse in the Arboretum. Then we have the orchid section. We have some very rare orchids with us, especially the Lady Suzanne's orchid, which Collett says common on the BCS spur. But today, if you go to the BCS spur, there's not a meter of soil left for anything to grow. It's all concrete today. So we have lost lots of our vegetation due to urbanization. So these rare orchids we have with us at the Arboretum. Then the center we have the Himalayan lady slip orchid, which was once very common in and around Simla, but today it is very difficult to locate. Besides this, we have a lot of outreach programs for school children, for kisans, for communities, for rural workshops. We hold a lot of capacity building forest department trainings. We get a lot of print and electronic medium to the Arboretum, which is very essential for its advertisement. And as well as national and international institutes come on a regular basis. So it serves as a consolidated open classroom for temperate native flora of the region. We hold a lot of international events in this Arboretum with school and college children. Now, if we see the role of the Western Himalayan Arboretum towards the contribution to the SDGs, well, besides SDG 2, the major contribution is in SDG 11, which states that make cities and human settlements inclusive, safe, resilient, and sustainable. SDG 11 also says that it directs governments to provide accessible green spaces by 2030 to all its citizens, especially the elderly, the ladies, and the children. Then the target, the goal 13 is also it comes under this. This says take urgent action to combat climate change and its impact. So it helps in climate change mitigation. The SDG 15, protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, combat desertification, and halt and reverse land degradation and biodiversity loss. So it helps in stopping biodiversity loss. Now, like I said, the importance of SDG 11, more than half the world, like I said, live in cities, and this trend is expected to continue. We will be, by 2050, 2/3 of us will be urban dwellers. That's why this goal is so very important. It's like 11.7, target 11.7 of the goal says that by 2030, provide universal access to safe, inclusive, and accessible green and public spaces, in particular for women and children, elder person, and person with disabilities. With respect to target 11.7, botanical gardens and arboreta provide green and public spaces for residents in many of the world's major cities. Now, the future priorities of the Arboretum are to provide green public space, and this Arboretum can promote and advise on tree planting and tree health for Simla and nearby developing towns, conservation of urban biodiversity, ecological restoration with native species, aggressive public awareness, germplasm bank for the lesser known tree species, and urban forestry plantations, gardening, and many other things. Safeguarding the components of biodiversity ex situ in an Arboretum will play a great role in ensuring that this biodiversity remains available not only to support present day and future use, but also that such native plant diversity be available for restoration and management purposes too. In the end note, I end this that the region, is unique because it replaces each other, the forest communities along altitude and climatic gradients. And this region has a lot of endemics. This developing Arboretum will contribute an enhanced understanding of native trees in mountain ecosystems with respect to the Northwest Himalaya. It will address local as well as regional plant conservation strategy and priority. Although encouraging progress is being made in some areas toward conserving and sustainably using native plant diversity, these efforts are not enough. It is essential that CBD with government organizations further engage with partner organizations to make the best use of available expertise and find ways to fully involve such efforts to enhance native plant conservation to aid the sustainable development goals. Now, what needs to be done is more sustainable development with renewable energy. We need to involve communities at all stages of all policies and projects. We need to have strong environmental laws. We need to restructure our tax system with the green in mind. Reform education with more stress on environmental courses. We need to work in groups and not in isolation. And more importantly, activism, protesting, and whistleblowing is the need of the hour. These I call my Vibhyo, the rainbow colors, and I end with the words of John Burnside that a modern arboretum brings to us the forest and with it a changed apprehension of time, a renewed appreciation of the elegance of natural form, and a renewed sense of wonder at the variety of the world we inhabit. Thank you. Any questions anyone would like to ask?
Thank you, sir. Yes, sir, we have a few questions from our participants. First question is, how does the Western Himalayan temperate region contribute to water resources and watershed management?
Could you come again, please?
Yes, sir. How does the Western Himalayan temperate region contribute to water resources and watershed management?
Well, see, this arboretum is spread on an area of around 2.5 hectares presently. So the plantation activities, because we are having, trees, shrubs, and the ground cover itself is covered. So if you see any ecosystem, any forest ecosystem, which is, covered with vegetation, it is going to help in whenever the rain comes, it's going to trap, it won't let it flow down very easily into the nearby stream. Like if it's a degraded area, what will happen, the rain which we get, especially in these days, the rain is coming in, in a very few, a little time, but more velocity. So what happens is when this rain comes, it flows down into the nearby stream, taking along with it the soil, which is, not without any vegetation. But if you have a, vegetative cover, especially of trees and then shrubs in 3-tier system, the rain is going to, the impact on the soil is going to impound it in a very, gentle way. So it gives it time to, get absorption into the soil. As such, it will aid, to store the water and not let it flow easily into the nearby streams. Ma'am, you have to unmute.
Sorry, sir. So second question is, can you give some insights on how mask awareness can contribute in flora conservation?
In solar conservation?
Flora conservation.
Okay. See, I've been into, my aim is this. It's this, like I said, this is a dream project for me. So every year we have more than almost 3,000 to 4,000 children visiting this place. And why I say children are the ones, who need to be educated and made aware, because they are the ones which is our future. And they're the ones who are going to really, take it upon themselves to do something constructive. And what we do is, like, whenever we have these international programs or these environment days or what we celebrate, otherwise also we have these inter-school skit competitions very regularly. We're having one on the 5th of June where we have invited a lot of government schools to have a 5-minute skit inter-school competition on environment. So these awareness is not only for children, even the rural areas. It's very surprising that people are not aware of most of the things, what is going to happen with climate change and global warming and the loss of our biodiversity.
Thank you so much, sir, for such an enlightening session.
Thank you.
Now I welcome Dr. Manoj Chandra Garg for the hands-on instrumentation training. Dr. Manoj Chandra Garg has 9 years of vast and rich experience in academics and research. He is MTech from Thapar University, Patiala, and a PhD from the Indian Institute of Technology, Roorkee. His postgraduate specialization is in environmental science and technology. He has published several research papers in reputed SCI journals and a total impact factor of more than 80. He had worked on the treatment of brackish groundwater by membrane water filtration system powered by the social photovoltaic system. He has an experience on lab scale as well as pilot scale. RF RO membrane filtration system. Presently, he is working on the forward osmosis system for the treatment of wastewater. Dr. Manoj Chandra Garg has filed 5 patents on membrane-based water and wastewater treatment technologies. Welcome, sir. Over to you.
Am I audible now?
Yes, sir, you're audible.
Okay. So thank you, organizers, for inviting me in this 5-day faculty development program on the building and sustainable future with the green technology, innovation, opportunity, and challenges. Now I just want to share my presentation. Just a minute. Is it visible on full screen mode?
Yes, sir, it is visible.
Okay, so my presentation is basically focused on the ICT tools, instrumentations, and the virtual lab in environmental system. Okay, so one by one we will see the things. Now we are talking about the software that basically used in the field of environmental sciences. First of all, you just like to see the tools that is basically used in the environmental sciences pertaining to the air pollution. That is a windrose plot. That is a very common plot that's basically used to see the different metallurgical doing the different applications on the field of environmental sciences like EIA or windrose basically the analysis of the wind data that is a fundamental in many sectors like the metallurgy and the climate, air pollution, air quality evolutions, architecture, energy productions, outdoor sports performance, agriculture, and many other sectors. And the windrose diagram is basically a tool which is graphically display wind speed and wind direction at a particular location over a period of time. So the diagram is normally comprises of 8 to 16 or 32 radiation spokes, which represent the wind directions in terms of the cardinal wind directions, north, east, south, and west, and their intermediate directions. So metallurgists use the windrose diagram to summarize the distributions of the wind speed and directions over the defined observation period. Okay, and data taken from the weather stations, which should be near and possible with the project site. So there is some freewares and softwares or applications are available to draw the windrose diagram. Okay, so as you can see, the WR plot view is a freeware that is available. When you Google it, you can be able to find the software WR plot. And if you have data of your particular location pertaining to the wind direction, wind speed, and this you can see in the other things, you can easily plot the windrose diagram with the using this software. Apart from this WR plot view, the Windrose Pro, that is also a one software that is basically used, commonly used for the plotting of the windrose diagram. Windrose Pro is a window application basically for analyzing the and plotting the directional variables starting from the raw data or from their frequencies basically. It is used to represent the windroses as well as the other directional variables. So as you can see here, the windrose WR plot not only show the windrose direction, windrose data, it also you can able to plot the rainrose direction, rainrose plot also. The rain data basically. The Windrose Pro is a window application for analyzing the plotting directional variables starting from the raw data, and it can be used to represent the windroses, but it is also possible to represent any other directional variables. Okay, and the windrose is a chart that which gives a view of how the wind speed and wind directions are distributed at a particular location over a specific period of time. So it is a very useful representations because of the large quantity of the data can be summarized in a single plot. As you can see, in this type of mat file, you have to upload on the software, and after that it can be able to draw a Windrose plot or Windrose diagram that basically represent the frequency of the wind speed on a particular direction, right? And you can also plot the frequency distribution and also the rain rose diagram if you're having a rain data, like how much amount of the rain or the precipitation intensity in mm per hour is there in a particular location in particular direction. That is a very good software basically that is used to draw a windrows and a rain rose diagram. Apart from these, the eDraw is a 2D. Whenever we are writing some proposal or writing some dissertation work, this eDraw software is very useful tool to draw a schematic diagram or the or the process diagram, flow charts, and other things also. So eDraw Max is a 2D which is technical diagrammatic software which helps to create the flow chart, organization charts, mind map, network diagrams, and workflow diagrams, engineering diagrams, and many more. And it's having a near about 1,500 built-in templates and over 26,000 symbols that basically inspiration for the diagram creations tools basically, right? That is basically this type of diagram can be drawn from the eDraw. There is a flow chart diagram of your process, all right? And this is the flow diagram. You can draw a flow chart with this software very easily. And after that, do you want to measure the sound level? So this is a smart sound level meter app for the Android. It is commonly available on the Android phones. You can download it from the Google Play Store. If you type the sound meter app or sound level meter app, you can easily able to download these type of app from the Google Play Store from the Android devices. This is a decibel meter basically used your built-in microphone to measure the sound volume in a decibel and also display the sample on the graphs. So microphones in most of the devices are aligned to the human voice and maximize the value for the limited by the hardware. So very loud sound near about 90 decibel or more may not be recognized, but some range of the sound can be recognized by this app. In decibel, you can see the decibel level of the sound. Common sounds are there in this table, and this is the interface of the sound level where you can able to see your level of the sound or your location. Okay, real-time variations, sound intensity can also be measured, and sound intensity in decibel you can measure by the help of this app. So this is the one app. Okay. Apart from this, if you want to measure the intensity of your light, so light professionals use the light meter, or you can see the lux meter or illuminations meter or lux meter to measure the amount of the light in a space or a particular work space. The light meter has sensors to measure the light falling on it, and it provides the user with a measure illumination readings. So lux meter is basically a simple light meter for measuring the luminescence in the lux by using the light sensors in your Android devices. So that is also possible with the help of Android app. If you type the lux meter in your Google Play Store, you can easily find this app in your Android devices. So locate the light sensor on the device. It is usually near the top of the front of the phone or the side of the screen. So you can do it by running your finger over the surface of the phone, and while your lux meter app is open. So when your finger is covered the light sensor, the reading should be dropped in the lux meter app. All right. So apart from these, in the environmental sciences, we are also using some environmental models like predator prey model. So there is some Excel sheet based software is available, easily available on the internet. If you Google it, then you can easily find these environmental models. For example, the Lotka-Volterra model, or we are also known as the predator prey model, where you can see the changes of the intensity of the population of the predator and prey. As the predator prey population is increases, their prey population will be decreases in such a way. So it basically equation based modeling. So there is some equations given by the Lotka-Volterra. Okay, and these equations are basically help us to draw a representation of the pictorial representation of the predator prey population. Right. Apart from these are some other software which can easily able to identify the ions intensity or the ion balance. Okay, if you have the ion concentration of your water sample, you can able to draw a Piper diagram for different samples. So Piper diagram software Excel-based Piper diagram software can also available freely on the internet. You can able to download it and you can use it to prepare a Piper diagram for your different samples based on the concentration of the ions present in the samples. For example, the chloride, sulfate, calcium, magnesium, and sodium, potassium. All these anions and cations based on the concentration of the anions and cations of the different sample, different locations. You can able to draw a Piper diagram of the. So Piper diagram basically propose an effective graphic representations for the presentation of the water chemistry data that basically help to understanding the source of the dissolved constituents of the water. And this basically procedure is based on the premise that the cations and anions in the water is generally a chemical equilibrium. So the main purpose of the Piper diagram is to show the clustering of the samples and the hydrothermal chemical phases of the sample and the cluster of the samples. Okay, so this is the Piper diagram software that you can easily find it on the net. It is freely available, Excel sheet based software. And the UG students, PG students, research scholars can easily taking the help from this software to augment their dissertation in their thesis. Now, it is a very useful software for optimization of the experimental variables that is known as the Design Expert software. Design Expert software is basically a statistical package from the state is INC that is specifically dedicated to the performing the design of that experiment. Okay, and Design Expert offers the comparative test, screening, characterizations, optimizations, and robust parameter design, and mixture design and the combined designs. Okay. And origin of the proprietary computer program is a interactive scientific graphing data analysis. Okay. So this software is basically used for the optimization of the data, or you can say the experimental data. For example, we can see on the screen it is showing that we have optimized the 3 parameters. Okay. For the 3 parameters, you can see the 19th experiment will designed by the Design Expert software with a different reading. So you have to fill the different ranges of the of your input factor, input parameter. Also, you have to fill what may be the output factors of the responses for the experiment. So Design Expert software will design the experiment as per the ranges given by you. So with the 3 or 4 input variables, you can do it for with the 2, 3, 4, 5 variables up to, so number of experiments will increase as you are increasing the input variables. So this software basically after the experimentation, you have to fill the output parameters, and after that it will give you the ANOVA results of the experiment, whether your experiments, all the experiments will become significant or not. And on the p-values and the lack of it, you can see the standard deviations, mean, coefficient of variations, R-square value, adjusted R-square value with the help of the software. And it will give the final equations in terms of coded factors. Okay, so it basically gives the model of your experiment that you can apply to validate your experimental setup, or if you want to do this on a particular on particular instrument, then this model will be applicable to that instrument also. So this type of 2D graph will be given by the software designer for software. So that basically gives the interactions between the two variables with the one responses. Here you can see one responses is the pressure, and two input variables will be the chromium removal and the chromium concentration. And this type of 3D graphs can be also be generated by the software that basically tells you about the interactions of the two input variable with the one output variable. So these two input variables are there: pressure, chromium concentration with the chromium removal. So you can see this is the output responses, the output variable, the output parameter, and these are the input variables, pressure and the chromium concentration. So these interaction of these input and output variables are represented in the form of 3D plots with the help of the software. So it will give you the more informative information about your experiments and optimize. And it also helps to optimize the variable input variables of your experiment. Now, this is also a very useful software that is the Origin, very much used by the research scholars and the PG student and the UG students to plot the diagram. Origin is basically a proprietary computer program for the interactive scientific graphing and the data analysis. It is a product of the Origin Lab Corporation and basically run on the Microsoft Windows. It is a graphing supporting, and Origin include the various 3D and 2D plot types. And data analysis in the Origin includes the statistical analysis, signal processing, curve fitting, and peak analysis. So that is a very useful tool to plot the graph in a very good way. Apart from this, you can also represent your data in the graphical manner in the Excel also. If you are comfortable with Excel, that is also a very good tool. But Origin will give you the more information, and it will give the more tools to represent your data in a graphical way. Now, that is also a very good tools when we are talking about the reference writing. Whenever we are writing a report or dissertation report or the thesis report or any other report, any scientific report. So the reference addition is very important area, and this software will help you to organize the citations and these references in your report. EndNote is a commercial reference management software package used to manage the bibliography of the references when writing essay, reports, and articles. It is currently produced a Clarivate Analyticals, and EndNote is a bibliographical management software that organizes the bibliographies and references when writing an essay, articles, and other manuscripts. And the software helps to manage and organize the references, insert in text citation, and generate the appropriate reference list. And there are various methods to insert the citation into the document. In general, basically the students are used it by manual way, but these type of software basically used to help the students to manage and organize the references in their articles. Insert citations toolbars options can be used in the Word to find the citations or insert the selected citations. You can also directly insert the citations from the EndNote and copy and paste the citation from the EndNote to the Word. Okay, so these apart from the EndNote, that is the reference citing software, There is other softwares pertaining to the reference writing is the Jotero as a freely available software. However, the EndNote is a paid software, but the Jotero is a freely available software. If you download it, the toolbar of the Jotero will show on the ribbon of your Word file. You can easily manage the your references through Jotero. Apart from this Mendeley software can also be used by the students to manage the references. And the Mendeley is also freely available software. However, I feel that comfortable with the EndNote. It is a very user-friendly software, but it is it is not a freely available. Apart from that, Kahoot is a very best played in the group setting to assist the students with the various type of topics. Kahoot is basically a gaming software that basically to join the game you need a unique pin, and your game will be hosted. So you have to the organizer will basically forms a quiz in the form of the MCQs that is basically interface online, and when you are able to the players answer their own devices. So when you give me the unique pin of the Kahoot to all the players, or you can the students, the players answer their own devices. They can use the mobile phones also. So while the questions are displayed on a shared screen, so you have to log into the Kahoot.com and log into their account, and in the Kahoot quiz pages that you have to choose the classic players, and so students enter the pin in the Kahoot and can able to play the this quiz. It is very interactive quiz. Then very interesting quiz platform Kahoot. Okay, and students very enjoyed this platform whenever they are doing the. You can easily assess the students also through this platform. This is the interface of the Kahoot. Okay. Now, nowadays the AI and machine learning is also very much famous in the environmental sciences. So we just we have done some exercise on the based on the machine learning in the environmental sciences. So basically, the data analytics methods that teaches the machine learning to the learn from the experiences, and it is a natural pattern in the data are discovered by the machine learning algorithm, and that can provide the understanding to make the direct predictions. So machine learning tool will tell you about is that basically tells you about the equations of the black box that you have not known about your experiments. So that is basically a tool that help you to make a model of your experiments. So we have done a small exercise. I'm not on the quality of the air quality data. So what we have done, we have collected the data from different sources, air quality data from different sources for the different parameters like PM 2.5, PM10, ozone, nitrate, sulfate. So it is NOx and SOx and CO. And we have calculated the overall AQI, and the 70% of this data, as you can see on the green graph, green color, 70% of the data we have give as an input in the artificial intelligence in the form of we have used the MATLAB tool in the MATLAB ANN tool, artificial neural network tool, and here we have given the 70% of the total data in the in this tool, and for the training purpose, and 30% for the validation purpose. Okay, as input data, and the AQI data we have given as a output data in the same training and the validation, and these other data we have used to for the testing purposes. So this type of best performance in the training statistics we have found. I'm not go deep in this type of all this type of graphs. So now when we're talking about the instrumentation analysis on the environmental sciences, then spectrophotometric analysis, I just give the overview of the spectrophotometric analysis, and we'll tell you what is this. That basically help the students to understand basically what is the statistical, what is the spectrophotometric analysis. Spectrophotometric techniques are used to measure the concentration of the solution by measuring the amount of the light that is absorbed by the solution in the cuvette placed in the spectrophotometer. Spectrophotometer is basically very commonly used in the environmental sciences. Spectrophotometer can measure the amount of the light electromagnetic radiations transmitted is absorbed by the solution. That is the basic principle of the spectrophotometric analysis. Now, what is the principle behind it? The principle behind the spectrophotometer is the absorption of the radiation energy. So, as we know that our radiation energy is having a wave particle nature. So, light and other forms of radiation energy have the dual nature. There is a wave nature also, the particle nature also. So, electromagnetic radiations is basically a type of the energy that is transmitted through the space and transfers wave the enormous velocity. It takes the numerous forms of the known as the electromagnetic spectrum, and the electromagnetic spectrum includes the gamma rays, X-rays, and other types of rays, UV, IR, and visible rays also. So these are the electromagnetic radiations and their ranges of the wavelength. As we all know that the visible light is ranging from the 400 to 700 nanometer, and in the spectrophotometer generally we use the UV lights and the visible light that is fall in this range. Okay. So polychromatic light, basically the white light is having a polychromatic light, and which contain the whole spectrum of the wavelength of the visible region that is passed through the object that basically absorbs a certain type of wavelength and leaving the unabsorbed wavelength to be transmitted. So these residues transmitted wavelength will be seen as a color. So color is complementary to the absorbed color. Okay. So absorption is a process in which the chemical species, like for example, the atom, ions, or the molecules in a transparent medium selectively attenuates certain frequency of the EMR. And the absorption spectrum is a plot of the amount of the light absorbed by the sample as a function of the wavelength. Okay, so at a room temperature, most of the substances are at their lowest energy or the ground state. When the atom or molecule is absorbed the EMR, it is promoted to the highest energy state and excited state. And excited states in the transition one. So whenever they gain the energy, they are excited and jump to their higher state level. So this is a very temporary condition. When they go back to their ground state, they emit some lights. Okay, they emit some lights of a particular wavelength, specific wavelength. So as I already know, I told you that whenever the atom to the molecule gaining the electromagnetic radiation, they jump on the higher energy state. Okay, first excitation state and the second excitation state. When they go back to their ground state, they emit some light. And when the molecule interact with the photons of the UV or the visible radiation, excitation of the electrons takes place at the higher end electronic energy level at any of these its vibrational level. Okay. So UV visible radiations causes electronic transitions when which is accomplished by the vibration and the rotational. So the sum total of the energy is basically the energy of the electronics as well as the vibrational as well as the energy plus the energy of the rotational energy. Okay. So as you can see, it follows the Lambert's and Beer's law. So okay, that basically tells you about the intensity of light is proportional to the concentration and the concentration is basically okay. So intensity is it falls about the cuvette intensity. I naught is basically incident light, and I1 is basically the path light, and which is proportional to the concentration and the path length of the cuvette. Okay. So as I already told you, this source is having a polychromatic light, which basically convert into the monochromatic light, and when it passes through the cuvette, it absorbs some light and reflects some light. It absorbs some, so we can do it with the help of absorption and the transmittance of the reflect by the reflector. So spectra are basically two types: absorption spectra and emission spectra. Absorption spectra is basically when the EM radiation of the different wavelength passes through the samples, one after the another, and some wavelength absorb the effectively than the others, and the others may not be absorbed at all. So resultant spectrum is the characteristics of the substance concerned. The maximum absorption by the sample occurs at a fixed wavelength. So absorption spectrum is one thing, and then the emission spectrum is that when sample is affected thermally or electrically, and more intense radiation fix the wavelength at a certain wavelength as the indicator of the substance. The main objective of analytical techniques are to identify the elements or the metals, that is the qualitative analysis, and the quantity of the identified component, that is the quantitative analysis. Okay. So spectrophotometry basically based on the fact that the compound absorbs the light radiation to a specific wavelength. It mainly based on the Lambert-Beer law, as already told you. The absorption of the or the optical density and the transmission of the transmittance. So there are two things are there: absorbance or the transmittance of the light can be calculated by measuring the light intensity at the entrance and the distance of the sample. Absorbance is measured by the log of the ratio of the radiations falling upon the sample and the radiation transmitted through the sample. So the logarithmic of the I naught by I, that is basically equal to the absorbance, which can be written as the A is equal to KCl, where K is the molar resistance coefficient, C is the constant measured by the cuvette, and L is the power length of the cuvette. Okay, so considering the monochromatic light transmitted through the solution, which is incident intensity, that is the I naught. I naught is the incident intensity, and I is the transmitted intensity. So transmittance is a solution is defined as the ratio of the transmittance intensity I over the incidence intensity I naught, and take the value between 0 and 1. So you can say 3 is equal to I by I naught. However, on the earlier slide, we have seen that absorbance is the logarithmic value for the I naught by I, but it is just opposite with the absorbance. Okay, so each wavelength of the light passes through the spectrophotometer. Intensity of the light passes through the reference cell is measured, and this is equal to the referred to the I naught or the intensity or the I. Okay, so that we already discussed Lambert and Beer's law. Not go deep in the Lambert and Beer law. So basically, in the UV visible spectrophotometer, or the instrument for the measuring the absorbance of the UV and visible radiations are made up of these components. Okay, so basically you can see there is some light source are there, which can be the UV or visible depending on your spectrophotometer, and then monochromator basically convert the polychromatic light to the monochromator light, and it passes through the one adjustable aperture, and that is basically placed before the cuvette, and in the cuvette your sample will be placed, and after that some light is absorbed by the whatever the fluid is filled in the cuvette, and some light is become reflected back, and basically sensed by the photoresistor and amplified and show in the form of output on the computer or the spectrophotometric screen. So you can see the curve between the percentage transmittance and the path length is, you can see in the form of exponential curve relationship, and the curve between the absorbance and the path length of the absorbance is shown in the form of linear curve relationship. So in each and every instrument, when we are talking about each and every instrument, then there should be one calibration curve that is basically, it tells you about the absorbance or different type of absorbance in the different concentration. You have to make a calibration curve with the different concentration of the solutions of your solution of the concern. Okay, accordingly, the absorbance is recorded by you, and you have to make the curve between the absorbance and the concentration. It should be linear curve, and R square value is approaching to the 1. Yeah. So, and based on this calibration curve, you can measure the value of your unknown sample with the help of this curve. This is the basic principle of each and every instrument. The calibration curve may be the linear calibration curve, non-linear calibration curve, and linear calibration curve of the Beer's law. Okay. So that's the applications of the spectrophotometer is basically in the chemical analysis, food safety analysis, blood analysis, DNA RNA concentrations, residual pesticide analysis, residual fluorine analysis. So I just give the overview about the UV spectrophotometer. Now in the spectrophotometry, as I already told you, there are two types of spectrophotometry there. One is the emission spectrophotometry, another one is the absorption spectrophotometry. So flame photometry is the emission type of the spectrophotometry. Just look a brief about this this flame photometry. Flame photometry is a branch of the atomic spectrophotometry that is used for determining the concentration of the certain metal ions such as the sodium, potassium, lithium, calcium, and the cesium. Okay. And there is a basis of the spectrophotometer working is that the type of the metal and the dissociated due to the thermal energy provided by the flame sources. Okay, due to this thermal excitation, some of the atoms are excited to the higher energy level and where they are not stable. Okay, so this is the basic principle of the this energy, and subsequent loss of energy will result in the movement of the excited atom to the lower energy level, ground state level, with the emission of certain radiations as a wavelength. And emitted wavelength are specific for the specific elements. Okay, so I already told you whenever light, whenever the atoms are excited by certain energy, and so they excited to their higher energy level, their higher energy excitation level, and this excitation level is transition state. And when they are coming back to the ground state, they emit some light, and these lights are specific to a specific element. Suppose if this flame photometer is basically used for the alkali earth metals, and this alkali earth metals is basically having a specific for the specific wavelengths. So this is a schematic diagram of the flame photometer. As we have some sample that we want to analyze. First of all, we have to aspirate our sample in the form of aerosol over the flame. The flame can be used in the form of LPG, or we can use other sources. And there are different type of flame photometry now coming nowadays in the market. But you can also use the different sources of the energy. So on the flame, you can aspirate your sample, and that basically the ions, whatever the molecules are present in your solutions are surrounded with this different data, the mist of the water, and surrounded by the water. On the flame, this water has become evaporated, and this molecule is now converted into the different atoms that basically excited with the help of energy given by the flame. So whatever the molecules are present on the flame had excited and absorbed the heat and jump to the higher energy level. As you can see, jump to the higher energy level. And this, as I already told you, it is not stable. It is not. It is very transition state. So when they convert, they come back to return back to the ground state. They emit some characteristics of the energy wavelength that is measured by the detector. This is the basic principle of the flame photometry. Okay. And the solution containing the metal to be measured by the first aspirated to the burner, as I already told you, and the solvent then evaporated, leaving the fine divided by the solid particles. And these solid particles move toward the flame, where the gaseous atoms or the ions are produced. And the atom absorbs the energy from the flame and excited to the high energy level. So these are already told you all these things. And when the atoms return to the ground state radiations, a characterized element emits the characteristics wavelength, and this intensity of the emitted light is related to the concentration of the element. So there are two things we have to measure. One is the qualitative and the quantitative analysis. So as you can see in this table, the different elements that is measured by the flame photometer having a the characteristic emitted wavelength. For example, the potassium is having a 766 emitted wavelength, and observed color of the flame is also a specific for a specific element. For example, in the case of potassium, it is a violet. When the color of the flame is red, then it should be the lithium. It is orange, it is the calcium. So yellow is sodium and lime green is the barium, and they have the characteristic wavelength emitted. So by measuring the emitted wavelength, you can easily measure what is the element and what is the intensity, what is the concentration of that element also. Okay. So I am not go deep in the different components and other things in the flame photometer. I just give detail of the flame photometry now. Now we are moving on the next instrument, that is the chromatography. All right. So just see what is the chromatography. Chromatography is a combination of the two words, chroma and the graphy. Okay, chroma means color, and graphy is represent the something on the paper, or in the form of graphical representation. Okay, so why it is known as the chromatography? So basically, the scientist, Russian scientist Mikhail Twitz in 1903, he continued the work with the chromatography on the first decade of the 20th century. Primarily, we used it for the separation of the plant pigment, that is a colored plant pigment. For example, the chlorophyll, that is a green color, carotenes having orange color, xanthophylls are in a yellow color. So they have used to separate this pigment. That is why they named it the chromatography. But here we are not used to separate the colors. We use the different pigments of different types of substances. Okay. So it is a physical separation methods for the separation in which the components of the mixtures are separated by the differences in their distribution between the two phases. One is which is the stationary phase, and another one is the mobile phase, moves through the defined direction, and substance must interact with the stationary phase to be retained and separated by it. So there are the two types of phase are there. One is the stationary phase, and another one is the mobile phase. Okay. So now we have a mixture of different components. We have to separate. We want to separate it. We can separate it with the help of chromatography, and these components can be used to analyze, to identify, to purify, and to quantify. So all these purposes we can use the chromatography. Whether we want to use to analyze it, we can identify it. What is these components? We want to purify it. If we want to separate it out some component from the mixture of the component, you can use the chromatography. You can quantify also. So chromatography is having, as I already told you, it's having a two components, mobile phase, that may be the different type of chromatography based on it. The mobile phase may be the gas or the liquid that carries the mixture of the components through the stationary phase. The stationary phase, as the name indicated, is the stationary, and it is a part of the apparatus that holds the component as they move through it or separating them. So it's basically having some solid particles or some liquid parts that basically fill in a column, and over it the mobile phase, that is maybe the gas or the liquid, are passed through it, and we have to inject our sample in the mobile phase. Through the mobile phase, that is passed through the through the column or stationary phase. And because of the different affinity with the stationary phase, they have separated out and they have different elution time, and that is the basic principle of the chromatography. So as I already told you, scientists are using the chromatography to analyze it, to examine the mixture of the components, their relationship with one another, to identify the mixture or the component based on the known component, to purify it, separate the components in order to isolate the one interest for the further studies, and to quantify it, to determine the amount of the mixture and the component present in the sample. So these are some real life example where we can use the chromatography. Pharmaceutical company are using it, hospitals, law enforcement, environmental agencies, and manufacturing plants. So whatever the visual output of the chromatograph is known as a chromatogram, and chromatograph is basically equipment that basically enable the sophisticated separations. And a stationary phase, already told you, is the bounded phase. Mobile phase, told you, the move, defined direction, and through which we have give our sample that basically run over the stationary phase, and because of the different affinity with the stationary phase, they have evolved the column at a different time. All right, so the retardation time we can measure with this formula, quantity of the substance in the mobile phase divided by the total quantity of substance in the system. Okay, now we will not go deep in the types of the chromatography, but I just give the overview of the types of the chromatography. I am not, because of time constraint, I am not giving the overview of all this chromatography. So there are different types of chromatography is there, like for example, the liquid chromatography that separates the liquid samples with the liquid solvents or the mobile phase, and the column components of the solid phase, and the gas chromatography that basically separates the vaporized sample with the carrier gas that basically having mobile phase. Okay, and the column composed of the liquid and solid beads of the stationary phase, and the paper chromatography that is basically commonly used to separate the dried liquid sample with a liquid solvent that is mobile phase in the paper is the stationary. The paper here is basically used as a stationary phase, and the liquid solvent is used as a mobile phase. In thin layer chromatography, that basically separates the dry liquid sample with the liquid solvents, and the glass plates covered with a thin layer of the aluminum or the silica gel or the stationary phase. Okay. So here we can also see the gel filtration chromatography. Gel filtration separates the molecule according to the differences in the size they pass through the filtration medium packed in the column. And it is a well suited for the biomolecule, for example, the DNA, RNA, and the protein and other things that is sensitive to the pH concentration in the harsh environment. And parameters that affect the gel filtration, the particle size, flow rate, packaging density, porosity, and particle and the viscosity of the mobile phase. So as you can see, we have the mixture of the big particle and the small particles, and we have the stationary phase, and in the form of beads. Beads are also having a pores in it. Okay, so gel particles having a pores in it. So basically, what happened? The big particles are moving fast. They are passing through the pores in between the beads or gel particles, but the small particles are entangled in the pore space of the gel particle and moving slowly in comparison to the big particle. So you can see the big particles having a different bands in comparison to the small particles. So they throughout the gel particle or the throughout the gel, they have showing the different color bands, different bands. So you can easily distinguish it with the help of markers. Okay. Now we have also having a different type of other chromatography like affinity chromatography and the HPLC, high performance liquid chromatography. I am not go deep in all this chromatography. Now you see the virtual labs in the environmental sciences. Okay, so virtual lab is basically very useful labs when we are talking about the instrumentation or the any other experimental work. So before going the actual experiment, I suggest all the UG, PG, and the PhD scholars to go through the instrument virtual lab so that you can easily acclimatize with the experiment and see. And you have to understand what is the basic principle behind it. You have to know more about the experiment. So before going the offline actual experiment, you should go through the this virtual lab experiments. So that is easily available, freely available on this website vlab.co.in. So you can see it and search it. Your environmental engineering lab. Okay, vlab.co.in. That is developed by the Ministry of Education, Government of India. So environmental engineering lab, you can see the different labs in the form of like TDS, TSS, LPT, hardness, chloride, total iron, pH, BOD, GOD, all these things. Okay, all these labs, all these experiments are listed over here. If you click on any of the experiment, you can find the aim, theory, pretest, procedure, simulation of that experiment. You have to, I recommend all the students to please go through the simulation of each and experiment before doing the actual lab, and then post test and the references also. MCQ, you have to attend the MCQ based question to enhance your knowledge about the experiment. Okay, and then procedure is also given. All the procedure is given over here. So you can easily take a benefit of all these labs over here. Simulation is also there. So all of you please go through the simulations for simulations of all these labs, and you can easily understand the things in a better way. Further, the calculation part is also given over here. So you can easily understand what is the calculation for what is the observation and the calculations. The virtual readings, you can find the virtual readings of each and every experiment. And with these virtual readings, you can easily understand the calculation part of each and every experiment. Thank you so much for giving me this opportunity to talk over this topic. Over to you, Charu.
Thank you so much, sir. So we have few questions from our participants. First question is, what are the challenges and limitations associated with the use of ICT tools in environmental science research and applications?
Sir, you are muted.
Okay, so am I audible now?
Yes, sir.
Okay, so as I already told you that when you are talking about the virtual labs or virtual tools or virtual labs, so you can able to take the preliminary knowledge about these tests, but the actual knowledge you have to do in the labs, in actual lab basically. But there's the one limitation. You can only do you can do the things virtually only. So it is good for gaining the knowledge, but as you are the student of the PG, UG, and the research scholars and the other streams, PhD scholars, we have to go through the hands-on practices in the actual lab. So this is the one limitations. Okay.
So second question is, can you provide examples of ICT tools that help in wildlife conservation and biodiversity monitoring?
Okay, so wildlife conservation. We can take the you can see the Amrita virtual labs, in which you can see the DNA fingerprinting that is basically help in the wildlife conservation when you are doing the DNA fingerprintings and RNA fingerprintings. So that you can take, and if you can search on the Google, you can easily find a very much ICT tools available for the wildlife conservation.
Thank you, sir, for your valuable time and much enlightening session. Thank you, sir.
Thank you.
Moving on, it's our honor to introduce our fourth speaker of the session, Professor Dr. Panuganti C.S. Devara. Dr. Devara is currently Director, Professor, and Head of the Centers of Excellence in Ocean Atmospheric Sciences and Technology and Environmental Sciences and Health at Amity University, Haryana, Gurugram, since March 12, 2014. After serving the Indian Institute of Tropical Meteorology, Pune, MUESGOI, India, at various capacities from December 1980 to February 2014. He is Fellow of the Royal Meteorological Society, UK, immediate past President of the Indian Aerosol Science and Technology Association, India, and Fellow of the Indian Aerosol Research Assembly, Taiwan. He has rich experience of more than 40 years in the active and passive remote sensing of the atmosphere, oceans, environmental health, wealth, and climate. His areas of research also include pollution monitoring, diagnosis, and mitigation. He is PI of several national and international collaborative research projects with global research organizations like NASA, USA Skynet, Japan, etc. He is an expert reviewer of IPCC, UNEP, NSF, EU funding agencies, Indian Space Research Organization, Department of Science and Technology, Ministry of Earth Sciences, Ministry of Environmental and Forest Climate Change, and many leading science and national and international journals. He has published so far more than 580 research papers in referred journals, proceedings, textbooks, chapters, and scientific reports. He has guided 12 students for PhD and 45 students for MSc degrees till date. He has received several awards, including the Eminent Scientist Award in January 2020, Lifetime Achievement Award in December 2021, and Best Research Award in February 2021, and many more. He delivered several invited talks on national and international platforms. He organized several national and international scientific conferences, workshops, and field observation campaigns in India and abroad. Presently, he is also a coordinator and closely associated with the research clusters in global warming and climate change and the space science and technology at Amity University. Sir, today we are honored to have you with us. And before we move ahead, as a part of Amity University tradition, we would like to facilitate you with a virtual Tulsi sapling as a symbol of love, respect, and gratitude. So I request you to kindly accept it. Thank you, sir. Over to you.
Good afternoon to all the participants, and particularly I would like to thank Dr. Charu Singh for her kind words, and also earlier introduced me to this audience by Dr. Juhi Gupta, Dr. Renu Duppar, Dr. Mrs. Brianna Khan, and Dr. Yeah. And then, in fact, I would like to start my talk because of the time constraint as quickly as possible. And at the beginning, I wanted to express my sincere gratitude to our founder, President Sir, Chancellor Sir, Vice Chancellor Sir, and Pro Vice Chancellor Sir. And in fact, I have, can anybody assist me for my presentation so that I can save time? I have already sent my PPT. So in fact, I have been enjoying for the last fifth day today, all the presentations. Particularly, I wanted to make small my own suggestions about the inaugural session. Of course, so many people have been talking about multidisciplinary subjects, and then many solutions and then mitigation processes they are suggesting about the pollution problem. Particularly, I wanted to remind all the participants only one thing, that whatever transformation you do from one energy to another energy, conventional to non-conventional or vice versa, always there are some unwanted emissions. They generate unwanted emissions. So we have to simultaneously work about the mitigation process, how to eliminate this unwanted emissions so that your mitigation process would be more and more pure and then more useful. That is one thing I wanted to tell. And then in fact, in this talk, can I have my presentation, Dr. Charu?
Yes, sir, sure.
Please. So, in fact, many exciting presentations I heard, and then I would like to thank once again the organizers for making this galaxy of presentations of multidisciplinary. And in fact, to solve this present day climate problem, a single institute cannot do much, but always international collaboration, national collaboration, multilateral collaborations are very much required. In fact, that's what actually I always suggest the institutional and the multi-institutional collaboration is very much required to solve the bigger problem of climate change. Of course, these are all, when you talk about the climate change, we can always remember that there are local climate changes, and then regional climate changes, and then national, and then continental, hemispheric, and then global climate change ultimately. So we have to solve this climate change problems. For that, we have to work very effectively the mitigation process and adaptation processes. And in my talk, briefly, I will talk about, of course, I planned for many things, but due to time constraint, I would like to quickly go through some of the slides, whatever I will be showing. And in fact, here, most of the things actually I will be talking about the fundamentals. Of course, details, of course, the time is not sufficient. So mostly I will be talking about the remote sensing techniques. What are the recent advances that have been taken place in applying these remote sensing techniques to tackle the bigger problem of climate change, climate system and climate change. And in fact, I would also be talking about, mostly I will be concentrating on, So this is my, in fact, I will be talking on recent advances and also the new challenges in remote sensing methods for sustainable climate. We are all working a lot in government always suggests about the how to minimize the changes or variations or variability in the climate. We cannot avoid completely climate change, but we can minimize through our techniques, whatever are under development are going to develop. So and my email ID is given here. I know that many people may be having many questions at the end of my talk. So because this is some of the recent advances I am talking about. So I always indicated my email ID there. They are most welcome to write to me. I have pleasure in replying to those questions. May I have the next slide, please? So here actually I wanted to reiterate the sustainable development goals. Of course, we have 17, but of course I will be in this talk, I will be concentrating mostly on the SDG number 13, that is climate action. So I will be talking about how actually the remote sensing techniques, what are the remote sensing techniques useful for studying this climate change and minimize the climate change. So in fact, we have to explore our sustainability research and find out how we are becoming a more sustainable business. Of course, this is a multifold subject and then multidisciplinary subject. We have to work upon the cost benefit ratio also. You have to keep in mind whatever technique we develop, it should be useful ultimately for the government, and then we have to solve certain problems. Say, for example, at the beginning itself, I told some unwanted emissions. So while simultaneously, while developing the technique for mitigation of any unwanted emission, toxic gases emission and or particulate matter emissions. So we have to simultaneously talk about, we have simultaneously find out, we have to develop the mitigation processes, how to avoid that, how to eliminate such unwanted emissions. So when I talk about some of the modeling techniques available and then whatever techniques we have been using and some of the experimental techniques, whatever I have been, I will be going to present in my talk. Next slide, please. So here actually, when you talk about the observational techniques, I will talk observational techniques and some of the modeling techniques, and also ultimately the how actually these observational techniques and the modeling techniques, why we need them, what way they are useful, and where you have to apply them effectively, and then how these techniques combinedly or standalone, they are useful for understanding the climate variability. So to investigate any atmospheric phenomena or oceanic phenomena or geophysical phenomena, we need the observing tools mostly consisting of experiments or observations and then models, and the validation calibration techniques for these models, we require observations and all. So when you talk about the observational techniques, we have a variety of ways of making the observational data inventory. We use ground-based techniques, and then we use balloon-borne, we use airborne, we use ship-borne, and also we use satellite data, space-borne. So where exactly this type of different type of data sets are useful, data sets can be made available. So when you talk about the experimental versus modeling techniques, of course, we need both. So why we need both observations and model? Because they are dependent on each other. Say, for example, experimental techniques are very much required for calibration, validation of the models, whatever we develop. So how actually modern techniques are required for experimentalists? So without having the modelers, we cannot collect the data or gather the data or conduct the experiments in a more useful manner. So experimentalists are required for modelers, models are also required for experimentalists. So ultimately, these two are hand in hand, they should go hand in hand. So when you talk about the methods, experimental techniques, we have generally the direct measurement techniques and remote sensing techniques. Of course, many of you may be knowing the difference between direct and remote sensing. Direct methods are available. They are also called as conventional techniques. We also call direct methods as conventional methods or surface measurement techniques. The name itself will tell you direct methods will methods will give you always the observations at the surface level. That what exactly when you talk about the very pertinent problem, global problem, not only global, national problem, prayer, the air pollution, etc., etc. So whatever observations we have, they are all confined to surface level. So that is not enough to understand the global level problems, like say, for example, climate problem. We require with height in space, how actually they are varying, whether you take particulate matter or you take a gas, and also how some of the measurements are available, column integrated. All these things in nutshell, I will discuss in my future, in my forthcoming slides. So here, we should know the direct measurements, how actually we make the direct measurements, how far they are useful for understanding the climate change. Say alternative thing is remote sensing. Remote sensing techniques also have some advantages, some disadvantages, but most of the remote sensing techniques usefulness is it can cover the entire globe Whereas direct measurements, they give point monitors. That's where they are also called point monitors or profilers. Horizontal profiling you can make. Vertical profiling is not possible with direct measurements. But of course, vertical profiling is possible. If you take the sensors through balloons or aircraft, we can make the vertical profile, but the entire process is very much cumbersome. So instead of going for that, alternative method is remote sensing. So you can, by sitting at the ground, you can get the vertical profile through remote sensors. I will give you the examples, and then of course some of the results wherever it is possible, I will give in my other slides. Next slide, please. So when you talk about the remote sensing techniques, basically again, there are two types of remote sensing techniques. So because this is FDP, I wanted to give more emphasis to the fundamentals rather than when entering very much deep into the techniques and all. So what is active remote sensing? What is passive remote sensing? So in any remote sensing techniques, we all should remember that there is a transmitter, there is a receiver in any remote sensing. Whether you talk about the radar, whether you talk about the LiDAR, whether you talk about the sonar, whether you talk about the SODAR, we have transmitter and we have receiver. So if you have the experimentalist or the observer have the control over both the transmitter and receiver, it is called active remote sensing. So if you don't have the control over the transmitter, there are passive remote sensing technique. This is the basic difference between active remote sensing and passive remote sensing. Say, for example, we use a lot of data inventory, very big data inventories, even for the modern techniques like AI, ML technique and big data science problems and all, we use satellite data. So that comes under passive remote sensing. So I will discuss some of the things, very fundamental things in my future slides. Next slide, please. So when we talk about the pollution, because why I chosen the topic of pollution when we talk about the climate change, because this is one of the burning problems, very much very dynamic parameter. Pollution is a dynamic parameter. So actually studying pollution is not a simple thing. It is a cumbersome process. So we talk about 5 types of pollution. Of course, 4 types normally we discuss, but I added here 5th type of pollution also. There is light pollution. We generally talk about the air pollution, water pollution, soil pollution, noise pollution also. Many people are discussing nowadays, but of course there is a light pollution, air pollution. So all these pollutions are very much important to understand the climate problem ultimately, because they contribute in many directions to the common problem of climate change or global warming, whatever way you want to call. So because air pollution is very complex thing, because it is mostly dynamic. It varies with time, it varies with the place. So it varies with environment in total. So it is very dynamic. So although very several advanced monitoring and diagnosis tools exist, mitigation and alternative process are very much stringent, and all we have to simultaneously think about and plan about the mitigation and adaptation process to minimize the changes or variability occurring in the climate. Next slide, please. Next slide. So my first question is, why to control pollution? We talk more about pollution. Why we should bother about pollution? So high pollution levels are very much hazardous to vegetation, drinking water, mortality, morbidity, COPD, strokes, and lung cancer. So many parameters, health problems, and then environmental problems we can encounter because of the pollution. Potential pollution sources include both natural. This is entire complexity involved in the pollution problems, because sources and sinks, when you talk about, some of them are natural, some of them are anthropogenic, and then they are not standalone problems, they are interdependent. So how to understand this type of complex problems? Unless we understand them fundamentals, and then only you can enter into the deep, and then unless both the at both the levels, these pollution problems are very much important for us to study and then understand. All the pollution sources or sinks lead to change in short-term, large-scale weather changes, climate changes in due to forcing, and hence regional global warming or cooling. Of course, some of the constituents, gases, and then pollutants are the particulate matter. Some of them are warming the atmosphere, some of them are cooling the atmosphere, depending upon their scattering and absorption properties. So these things, in a nutshell, I will discuss because of the shortage of time. So next slide, please. So next question is, Where to control the pollution? We know that pollution is required to be studied a lot to understand fully, but where to control? There are many sources available. So the most pertinent sources for this pollution is automobile sector and industrial sector, second one. So I will talk about the automobile sectors in nutshell. How to avoid this automobile sectors, how actually we measure this automobile pollutions. Of course, many producers, many speakers have talked about different type of sensors, different type of modeling techniques, how to measure these pollutants. But of course, how to minimize this pollution. Say, for example, automobile sector, whatever pollutants we are encountering. So how to minimize this pollution? One is the phasing out of petrol or diesel vehicles, because transport is one of the major source for this pollution parameters, which are causing ultimately the long-term variability in the climate change. And introduce electric passenger cars and improve fuel quality. This is another major parameter with which we can minimize the pollution problem. Mandatory BS standard vehicle. Review of traffic plans, including one-way traffic roads and parking places, reduce traffic lights and then create signal-free corridors, and implement of ITS, intelligent transportation system. So these are some of these. I am not saying that this is the total list. These are some of the parameters where some of the stages where we can improve the pollution which is coming from automobile sector. And then ion chemistry, this is one thing why I wanted to give a little bit emphasis on my last point. This is ion chemistry technique, this is negative ion generators. By introducing the negative ion generators, we can minimize the atmospheric pollution which is emanating, which is entering into the atmosphere through automobile sector. Because some of the techniques are very well used by many people in the country, but negative ion generators, of course, this is one of the relatively new concept which you can also develop to minimize the pollution which is coming out from the automobile sectors. So next slide, please. So this is another pollution source what we have been facing in our country, not only in our country, global. These are all global parameters which are contributing to the pollution at global level. Source control. One main important thing is that we have to control the pollution at the source itself. Thereby the propagation, thereby the transformation, all those phenomena can be reduced. And then recycling is another parameter where we can reduce some of the pollution problems. Cleaning of resources, industry site selection. This is highly important. So industry site selection is very important. Thereby we can reduce a lot of the unwanted emissions. Proper treatment of industrial waste. This is another thing. Of course, there are many the remedial measures have been invented by the scientists available in the country, not only in India, outside also. But one thing again I want to re-emphasize, that is during this conversion process, some of the toxic material, toxic gases which are emitting. So we have to plan simultaneously how to reduce them. Otherwise, there is no charm in identifying and then developing the mitigation process. We have to simultaneously work on that. Next slide. So alternative, see, this is one of the pollution source I wanted to emphasize in my short presentation today. There is crop waste or crop residue burning, parali burning, or stubble burning we call. So how actually we can make the alternatives for the stubble burning? Because this is the pollution normally we see in North India during the post-monsoon season. September, October, November also I can want to include, because in our studies we have this activity, it is seen in the September, October, November. So this is one of the very highly influencing pollution source. So the instead of burning and then making so much pollution, there are alternative methods given here as fodder for animals, bedding materials for cattle, mushroom cultivation, paper and cardboard production, making biogas, organic manure, mud bricks, and then wasteland smokeless chulas. All these are all alternatives one can plan for reducing instead of burning the crop waste. Next one. So the important gap, of course, this I wanted to come a little later. Next one, please. So these are all some of the models what you have been using. Of course, I think the next speakers, next one or two speakers also may be talking about the models. Of course, I wanted to hear only, I will touch upon the different type of models, what you have been, what are the models you use, and what are the models what you have utilized so far at MT University, Haryana. Box model, this is the simplest zero-dimensional, one-dimensional model, Gaussian distribution model. High split, of course, this is the long-range transport. How to identify the long-range transport? Local transports can easily, our sensors can capture, but long-range transport, there are models available like high split, hybrid, single particle Lagrangian integrated trajectory models, backward as well as the forward models, and chemistry transport model. SB dot, this is the other model what we use for studying the radiative forcing. This particulate matter as well as the trace constituents, characteristic pollutants, they exert a lot of forcing on the atmosphere. This is what actually Santa Barbara Desert atmosphere radiative transfer models we use to study the radiative forcing. Different gases exert the force and different ways and then different quantities. So at the bottom of the atmosphere, and the top of the atmosphere, and in the atmosphere, at three places we calculate the radiative forcing. Thereby we can study what are type of pollutants, different type of pollutants, or what way they induce the radiative forcing. And then DREAM, of course, this is another model we use for studying the dust, influence of dust on atmospheric pollution, global warming, as well as in the climate modeling. Air mod and AirQ models. So for health impact studies, these are basically dispersion models we have been using, and many people are using in the country. So these models are to be developed further because they have their own limitations. We have to come out from the limitations, or at least we have to improve the accuracy and then the resolution of these models. And one model, of course, which has been used, which is being used presently, is the Earth System Science model. This is very important model and then highly complicated, and then it includes almost all sorts of atmospheric, including the oceanic effects also, Earth System Science models. Of course, this includes even the novel nomenclature of Anthrosphere. Of course, we have been talking about the cryosphere, biosphere, geosphere, lithosphere, and then Anthrosphere. That is a new terminology which has been added to the climate change. So this Earth system model, of course, science model includes all sorts of these models, all sorts of these peripherals as subroutines in the Earth system model, which is a bigger model. Of course, it involves upscaling, downscaling, and almost, but one thing I want to emphasize here, even for this Earth system science model, we require high resolution data, inventories. So somebody, even my predecessor, previous speakers, even on other days also, they were talking about most about the AEML technique and then big data science inputs and all. But of course, all these models, even though they are very much used nowadays, but ultimately the model resolution depends upon with how we accurately are collecting the data, basic data. So ultimately the question remains, what is your data? What the accuracy of your data? Both spatial as well as temporal accuracies. And so ultimately we have to take more and more care about the collection of the data and then its accuracies. Next slide, please. So these are all, of course, I don't have much time here. I will look for another opportunity in the future, but I wanted to slightly talk about these systems. So one of the recent advances that have been taken place in remote sensing techniques towards the climate change monitoring is one of the things is LiDARs. So LiDARs full form is light detection and ranging. Of course, here like in radars, SONARs, sound detection, radars, radio detection, and then sonars, sound navigation research. So here actually we use light source as the transmitter and then telescope, optical telescope as the receiver. Of course, the first frame, you can see that that is a bistatic organon LiDAR. The green beam, laser beam, what you are seeing is the organon laser beam, 5145 nanometer, 5145 angstrom with the green light, which is coming out emptying from the organon laser, which we send all these laser beams, we send into the atmosphere. When you send the laser beam, laser energy into the atmosphere. The energy will be scattered and then absorbed by the particles, gases present in the atmosphere. So ultimately what we do with the telescope, we collect the scattered data, the absorbing data, and then that we will apply the inversion techniques to convert them into the concentration profiles. This is one of the important aspects actually we require now to develop in future to understand fully the climate change problem. So here, by inverting the collected scattered data and absorbing data, we can get the vertical profiles, height distribution of various gases and then various particulate matters, say for example PM1, PM2.5, PM10, and not only PM1. You see, we need to understand the ultrafine particles. Ultrafine particles, how actually their vertical distributions. This is the topic of nowadays. We have to understand to that level, then only some sort of more understanding about the climate change is possible. So the second frame, if you see, this is the Cassegrain Newton type telescope, which collects the scatter intensity. And then third frame, if you see that the ozone LiDAR, it measures the ozone profile, vertical profile, ozone concentration up to stratospheric altitudes. That means up to 50 kilometers, starting from surface level. So here you can see we use excimer laser, xenon chloride laser we use, and then also we use the pump laser. We use the shifter. So we use the 308, that is the nanometer principal wavelength, and 353, the offline. So we send both the wavelengths into the atmosphere and then shift difference between this return signals at 308 and 353 will give directly the ozone concentration. So this is one of the very, very sophisticated ozone LiDAR technique. And then side you can see that Cassegrain telescope, which is a refraction type telescope. So the first row, if you see the last one, that is wind LiDAR, which measures about the three components of wind, both horizontal, vertical, and then Z direction. So all the three components of wind it can measure start up to about 12 kilometers. So all other portable Doppler wind LiDAR, it can operate even when there is rain conditions. So we can operate this wind LiDAR so that you can get all the three components of winds. And then another thing is line of sight Raman LiDAR. So of course, you know the difference between ordinary laser remote sensing or any previous speakers are also talked about the spectrophotometer techniques. So there, all these techniques, when you get the samples and then analyze the data in the laboratory, they are okay. But when you want to apply these light signals in the atmosphere directly to get the vertical profiles or column integrated profiles, they cannot work because rain, it suppresses the return signal. So you will not observe anything. But this wind LiDAR has the system which can wipe off the telescope, which is acting as a receiver here. So it is a very powerful instrument. So even during rainy conditions also you can get the wind components. And then another one is you can see here line of sight Raman LiDAR signal. Raman, actually the beauty of this Raman technique is that you, for any profile measurement or for any gases, we need differential absorption. That means you need two wavelengths at a time, but in Raman, only one wavelength is sufficient. So the other wavelength, automatically the information comes at the shifted wavelength. So fundamental wavelength and shifted wavelength intensities, if you are able to measure, you can get number of gas constituents profiles, horizontal as well as vertical profiles you can measure. So one of the diagrams I have shown here, this is the line of sight Raman LiDAR, and then this is another one, this is micropulse LiDAR, which is very much portable, and then it can measure the atmospheric particulate matter and then some of the gases which are relevant to the probing wavelength of Nd:YAG laser. So up to about 120 kilometers. So these are all very recent advances, very highly useful for climate change. And then the other one is, this is another LiDAR, Raman LiDAR, which measures about the water vapor present in the atmosphere. Water vapor measurement in the atmosphere is very, very complex and then very typical. So these are all the laser-based systems with which we can get the not only the horizontal profiles and at the point monitors, just like a point monitor, but it can give the information about the height distribution, because we know globally or even the nationally there are strong layer stratification in the atmosphere at different layers. Either you take the particulate matter or you take the gases, some of the layers present in the atmosphere. But when you, as long as you make the measurements at the surface level, you will not come to know the layers presenting in the atmosphere. So that is the missing information here. So when you put the information into your model, all these parameters we are missing. So to get the complete information, to understand near complete information about the climate change, we require the vertical profiling also, height distribution with height actually. So these are all the LiDAR system which can help us in making the vertical distributions. So this is all active remote sensing, because the observer can have, experimenter can have control over the transmitter as well as the receiver. You can increase the laser power, you can decrease the laser power depending upon your application. So that's how actually these are all active remote sensing techniques. I will show you in the next slide a group of passive remote sensing also, because these are all the systems what we have already developed and demonstrated. Many results have been published. Of course, to paucity of time, I am not going to explain some of the results, but still I will try. So next slide, please. So these are all a set of passive remote sensing techniques. So what the difference? Passive remote sensing means you will not have, that means observer will not have any control over the transmitter. But here the transmitter is either sun or moon or star. So these are all photometers, spectrophotometers, if you are using more than a wavelength, one wavelength. So the first one is conventional filter wheel spectrometer. The second one is microtops. These are all the multivalent spectrometers. So the principle here is, when you receive this solar radiation, this radiation undergoes into different types of absorbing, different types of scattering, Mie scattering, Rayleigh scattering, different type of scattering techniques, different type of absorption techniques. They undergo, and the small quantity of energy available at the ground, at the receiver. That is, here the receiver is a detector. So in all the passive remote sensing techniques, detector are an array of detector or single detector. So at the detector, we receive, after undergoing this absorption and scattering of the solar radiation, we observe, and then using the again inversion techniques, we will convert this scattered signals or absorbing signals into the concentration of the various gases or particulate material, all aerosols. So this third one, if you see, high spectral resolution spectrometer with sun tracker, actually here we use, normally we use in conventional spectrometers or sun photometers, we use glass filters or narrow band filters of 1 nanometer bandwidth, full width half maximum bandwidth of the filter. But here in high spectral resolution photometers, we use grating spectrometer, we use as a filter wavelength. So thereby we can get the high resolution data even at the interval of 1 nanometer interval. We can get the aerosol optical depth. Aerosol optical depth is nothing but the optical attenuation. When the solar radiation reaches the Earth's atmosphere, how much is the attenuation taking place because of the molecules, because of the particles present in the atmosphere? How much is the attenuation? That information we get from this radiometers. So this is what we call attenuation or extinction. Extinction in simple terms, it is nothing but the summation of scattering and absorption. So polarized sun sky radiometer, simul sun sky radiometer. Of course, I will take few minutes more in my earlier after the forthcoming slides, but here actually I will simply principle I will explain. Here it is polarized one. Of course, if you have the radiometer polarization information, of course, every electromagnetic wave we have electric vector and magnetic vector. If the electric vector and magnetic vector, if they align each other, we get the co-polarization received wave. And then if they are perpendicular to each other, we get the cross polarization. So in a polarized radiometer, we get both polarizations perpendicular as well as parallel. So if you calculate the ratio between these two different type of polarizations, we can get the depolarization ratio. Depolarization ratio is one of the parameters with which we can study the very, very sophisticated information about the size of the particle. So this is the sophistication we are getting with the remote sensing techniques. So this is possible with if you have the, whether it is active remote sensing, whether it is passive remote sensing, if you add the polarization capable to that, we can get the information up to size of the particle, because the size of the particle, concentration of the particle, they are all the parameters which affect a lot to the climate change. Unless we understand these things, we cannot completely understand the ultimately the climate problem. So that's where I wanted to emphasize here. So polarization property is one of the things. Of course, I will take little more time in my other slides. Next slide, please. So these techniques, not only in the atmosphere or over the ground, we can apply them in the oceanic research also. Of course, I have listed here to cut short the time, parameter type of LiDAR and the accuracies, and then principles time of flight measurement, fluorescence measurement, and backscatter. These are all the type of lasers we use for oceanic research. Next one. So we can do many things for chlorophyll distribution, vegetation monitoring, and then oil spill. Of course, I will show some of the pictorial diagrams here, how actually this type of measurements are possible using the LiDARs in the oceanic research. Next slide, please. So this is one pictorial information talking about the bathymetry, laser bathymetry. We can see the upper surface and then below the sea surface, what are the undulations because of this surface returns. By monitoring both outer layer and then deeper into the water layers, we can study the depth layer depth variation temporally and then vertically also we can study by using the mobile platforms like aircraft by using the LiDAR system. Next one. Next one shows about the marine pollution. You see here we can see the very simple thing where oil spill over oceans. You can study this is one of the major source which contribute to the marine pollution. Of course, by using the Ruby laser, Ruby LiDAR from by downlooking Ruby LiDAR, we can study the oil spill or marine pollution, and then we can get the information. And then by mapping this oil spill over oceans, we can study how actually the sea surface temperatures are affecting, and then how actually the sea surface temperatures affect the water vapor, how actually the sea surface parameters affecting the climate change. So these are all very, very important parameters which are all highly possible with the active remote sensing and passive remote sensing using the laser systems and radiometers. Next one, please. So in this figure, actually, I would like to show the laser fluorescence. Of course, laser fluorescence, LIF technique, laser induced fluorescence technique. So this has multi applications, algae surveying, agricultural applications, oil spill detection, marine baseline hydrocarbon survey. So many fish detection, oil principle surveillance, air interaction, and rescue measurements, dispersion studies. Many things are possible by making use of the fluorescence using the laser beams entering into the pumping into the atmosphere upward and then downward into the water. So you can study many more parameters which highly contributing to our climate change. So next one, please. So here, actually, I will take few more minutes to explain in nutshell the ongoing and proposed climate and allied research activities at MIT University, particularly in MIT University, Haryana, Gurgaon. Next slide, please. So these are all, again, I wanted to emphasize the pertinent problems which are affecting the climate change, and not only climate change, our human health effect also. Major sources are automobile, biomass burning, and parali, stubble burning, crop waste burning. Ultimately, all these parameters affect the human health. So this is very, very important and immediate societal application. So long-term affecting pollutants like the other two, and then immediate impact on human health information. So some of the techniques what we have developed at the MIT University, I will quickly go through and then explain here. Next slide, please. So these are all the laboratories what we have developed at MIT University. So climate research laboratory, solar radiometry laboratory, air quality monitoring and diagnosis laboratory, AQMS. But of course, first frame, if you see CRL, climate research laboratory, these are all the suite of instruments, suite of laboratory what we have developed in collaboration with Aries Nainital. And then we have made a lot of measurements, and then particularly we have utilized this facility during the time of odd even measurements. And then, of course, we can see the air quality monitoring system. Of course, it measures almost about 22 parameters, 16 pollution parameters, and 6 meteorological parameters. So simultaneously measure, and then we study many parameters like the polluted PM1, PM2.5, PM10, and CO2, NOx, SOx, and then ammonia, and then volatile organic compounds, and 6 meteorological surface measurements like standard temperature, humidity, wind speed, wind direction, and also NASA Aeronet. Of course, down row, if you see the leftmost, if you see the NASA Aeronet, I will show the enlarged pictures also. So, and then this another academia industrial collaboration. This is a polarized nephelometer, multispectral nephelometer, which we have been operating at AUH in collaboration with Ecotech Private Limited, Australia. And then the right extreme one is very standard BC etholometer, black carbon measurement technique. So next slide, please. So this is the one what actually I have been talking about, air quality monitoring system. This, in fact, we have developed at AUH in collaboration with the Indian Institute of Tropical Meteorology. And then, of course, I have listed out the 22 parameters what it measures simultaneously. Time synchronization, sequential parameters. You can see here, these are all the parameters. Of course, some of the improvements what we require nationally and globally, also standardization of PM1. Of course, for that also we are making our own plans to make the standardization of PM1 and even smaller particles, ultrafine particulate matter and all. So here we can see the our AQMS, air quality monitoring system, which we have been using for data inventory, and then some of the models we have been using, some of the studies we have already published in many high impact journals. Next one, please. I am quickly going through, of course, our honorable chancellor, sir. You can see Dr. Asim Chauhan, and along with our AQMS system, and then our honorable chancellor, vice chancellor, sir, Professor P.V. Sharma, and then with our AQMS system. Next one, please. So these are some of the student activities where you can see our students are making measurements of solar radiometric measurements, and then ethanometer measurements, and then here we are also measuring by using this students are making measurements of bioaerosols. This is one of the measurements which are very sparse in our country. So we are improving these measurements by making the collaborative programs with the NERI, Nagpur. Next slide, please. So these are all the network systems available with SAFAR system for air pollution forecasting and research, and the MAPN system. Of course, what we have installed at our institute is the MAPN system we have been operating. This is the system, network system. Next one, please. Next one is CPCB, Central Pollution Control Board, which includes the State Pollution Control Board systems also. Of course, many people are utilizing the CPCB, including our MT universities also. So next one. So this is sun sky radiometer. In fact, when you talk about this sky radiometers, there are basically two sun sky radiometers. One is Skynet and the another one is NASA Aeronet. This is Skynet. The right one is Skynet radiometer. The left side is Aeronet radiometer. We use both the radiometers and then make, of course, we have published some of the measurements and then some of the merits and demerits of both the things, and with the combined operation of these two. Next one, please. So this is network of NASA Aeronet. Next. So almost about more than 450 NASA Aeronet stations have been in operation all over the world. Of course, MT University Haryana is one among them. And then we got very recently, this was established MT University Haryana in 2017. Several students completed the project and dissertation works using this NASA Aeronet GSFC USA, and nearly 50 research papers have been published by using this NASA Aeronet data and then Skynet data. And the prestigious, what I wanted to emphasize here is that very prestigious MOU, Memorandum of Understanding, we have signed. NASA, this MT University Haryana signed very recently in June 22 for the next 1 decade up to 2032. So here actually very recently, now we have received very, I think yesterday or day before yesterday, we have received the another system of NASA Aeronet that is unique in the country. So far, the NASA Aeronets in the country are operating only during daytime because their source is sun. So what we have got is day and night. This is solar lunar radiometer. So we use solar radiation as well as lunar radiation, moon radiations during night time, so that we get the column integrated aerosol optical depths both during daytime as well as night time. So thereby we can study the daytime boundary layer, nighttime boundary layer, single scattering albedo during daytime, nighttime, asymmetric parameter during daytime, nighttime. So all these parameters we can study during daytime and daytime, nighttime. So thereby lot of advantages in getting this data, columnar information, which will definitely aid the more and more understanding of the climate variability and radiation properties, day and night time measurements, round the clock measurements from MT University, Haryana, and also
Excuse me, sir.
okay, I'm coming to my last slide. Fastly, I know the time constraint. So this is the Aeronet system what we have developed at MIT University. Next one, of course, it gives a most about this. Actually, I wanted to emphasize. Take one more minute. So far.
Sir, you are not audible.
So now, am
Yes,
I
sir.
audible?
Now you are.
Okay,
Yes,
okay,
sir.
okay. So this is one of the very novel technique. Of course, here the system is called Maya Amod. Maya is the new satellite which NASA is going to launch next year, 24. And then we have already started developing the ground truth for validation and calibration of this NASA satellite. So this is the system. We have 4 systems present in the atmosphere. These are the systems we have been developed. We have been Emory University Health Research Center in collaboration with them and IIT Delhi, and then at MT University Haryana, we have developed this, and MT University Noida is also having this type of thing. Maya Amod. Amod actually it gives the optical depth just like whatever I have explained about the spectral radiometer or this NASA Aeronet system optical depths, and simultaneously chemistry of aerosols also get from filter technique. So by getting the simultaneous information about the chemistry as well as the physics and dynamics, we can study the variety of health parameters, and we can go to the details that which type of parameter, which type of constituent causes which type of disease. To that extent, we can study the health parameters using this very novel technique, which are going to establish. We have already started doing the calibration techniques we are developing at MT University. Now we are going to have MT net, MENet. So we are planning to have 4 to 5 simultaneous NASA Aeronet stations at our MIT universities, so that we can have our own data, and then this will be another addition to the already data inventory what we are having the country. So next one. So this is the NASA Aeronet MOU which we have developed last year, June 22. Of course, we can see our counterpart, Brent Holborn from NASA side, and our founders are, and then Chancellor sir, Vice Chancellor sir, and the right side is our MOU collaboration memorandum of understanding with IMD, which also we established last year. Of course, a lot of papers have come out already with this collaboration. The NASA Aeronet also have already almost about 50 papers we have already published in high impact factor journals. Next one. So of course, this you can skip. This I have already explained. So here actually I wanted to take 1 or 2 more minutes, because these are all new challenges and some future suggestions. Of course, again and again I wanted to emphasize, of course, whatever wealth of data we have in the country, they are all confined to surface level. This is not at all sufficient for studying the climate. So we require height variation of these pollutants, both particulate matter as well as the gases. That's what actually I have indicated here as height time cross sections. They are nothing but the height profiles, vertical distributions of characteristic pollutant mass concentrations. This is one of the very important thing. Of course, right now we have surface level measurements, and column integrated measurements, but not height profiles. Column integrated measurements will not give you the stratification structure of this pollutant of PM1, PM2.5, whatever pollutant parameter we got about, and then whatever gases we are talking about, including the toxic gases or we need to have height distribution of these gases. For that, we need to have boundary layer parameters, because that is one of the regulating parameters for regulating all these pollutants. So this height distribution is possible only through remote sensing, like whatever I have explained already. Height and cross section, bioaerosols. This is another area I wanted to emphasize here. Of course, very little information is available in the country. So MIT University, we are paying more and more attention in collaboration with the NASA and other, NERI and other organizations to study about the bioresources in both ways. How actually bioresources induce the radiative forcing and also its impact on human health. So in terms of fungi and bacteria, we wanted to study this bioresource. And then multidimensional mapping, structure stratification of pollutants using mobile platforms like mini LiDARs, ceilometers, drones, and then ships. Of course, with the drone also collaborative programs we are developing with NERI. And then standardization of PM1 and the superfine particulate matter, gas to particle conversion, and interplay between the within the gases and also particulate matter versus gases. So these are all interplay or interactions are required to be understood to tackle the climate problem, and also the gas to particle conversion problems. These are all the required to understand. And the pollution forecast models, of course, Gaurav and all, Dr. Gaurav and all probably talking about this, and some of the speakers have already talked in, they have touched upon the peripherals, which the forecast models which have originated through neural networks and deterministic AI earlier, and now AI and ML techniques, and then modules, dynamical modules, earth system science models, land, atmosphere, ocean, coupled models, how actually these models and all useful for forecast, and the artificial intelligence and machine learning, and then data science tools. And role of polar science, this is another thing actually I wanted to suggest. Of course, the third polar, our Himalayas also, we are concentrating now some of the Antarctic and Arctic chemistry as well as physics and dynamics and radiation. We have already published some papers, and a lot of work is going on at MIT universities, both Haryana as well as Uttar Pradesh. And scavenging, this is one of the things, actually this is nothing but the mitigation process, and actually we have to talk about, we have to understand how actually the particulate matter is playing a role in clouds and precipitation. They are the natural limiters, natural mitigating process. We should understand thoroughly the interactions between this particulate matter and clouds and precipitation. And we have to develop these techniques to, because they are naturally mitigation process already available. So without having any unwanted gases emissions and all. Influence of anthroposphere, of course, this I have talked about. These are all some of the things. Next slide, please. So having discussed all these things, I wanted to thank about, gratefully acknowledge the constant support, encouragement, cooperation, collaboration from our founder, President Sir, Dr. Ashok Chauhan, President MIT University, and Dr. Asim Chauhan, Honorable Chancellor, MIT University Haryana, Dr. Professor P.B. Sharma, Honorable Vice Chancellor AUH, Professor Dr. Vikas Madhukar, Honorable Professor, Vice Chancellor, AUH, all team members and funding agencies of national and international collaborators as well as the funding agencies, and governing council and directors of IITM Pune, Aris Nainital, IIT Delhi, DGM Director General of Meteorology, IMD, secretaries of MOS, DST, MOFCC, Government of India, NASA, NOVA, and CAR, and other Emory University, and then Australia, this funding academy industry collaborators. So thank you very much for giving me this opportunity to fastly sharing my knowledge. Of course, I'm very sorry I could not go deep into the detail, but still I tried to cover some of the things. Of course, I can share in future anytime whenever I get an opportunity, thorough thing. And then of course I have tried to given my message many gap areas are available. So climate is such a complex thing. Of course, lot of efforts are required. Of course, we have the capability. We can definitely do it. But only thing is collaboration very much required. Collaboration, intra, all these things I have been always talking about. Of course, I wanted to give some 1 or 2 questions from participant side. Actually, that's what actually I tried to explain some of the fundamentals instead of going into the deep into the results and then scientific interpretation and all these type of things. Thank you so much. Thank you so much once again, the organizers, for giving me this opportunity.
Thank you so much,
Thank
sir. So we have few questions from our
Sure.
participants.
Sure, please.
So first question is what are the challenges and limitations of using remote sensing methods for sustainable climate applications?
Yeah. So the first and foremost advantage of remote sensing is if you use any non-remote sensing technique, the spatial variability, wherever you make the measurement around that, spatial limitations are there. But in the remote sensing technique, all over the globe, you can study any type of phenomena, any type of parameter you can monitor. Of course, both direct as well as remote sensing techniques, you cannot treat them as standalone, they are interdependent. So all these remote sensing techniques, you have to have the calibration and the validation. Unless you do calibration, calibration validation, how powerful the remote sensing technique is, we cannot use it, you cannot make it as, you cannot treat them as reliable. So validation and calibration are required. So what is required for validation and calibration? Direct measurements are required. So these two are interrelated. You cannot separate them. So they have their own merits and demerits. But in this connection, actually, I wanted to tell one thing. There are satellites like Calypso. That is the first and the last satellite available in the globe, which has taken the LiDAR system, mini LiDAR, into the satellite. So it gives the LiDAR profiles, vertical profiles from satellite also. Normal, otherwise, satellites give only column integrated. Satellites look from top to bottom, whereas direct measurements techniques look from bottom to top. So there are a lot of interactions. When clouds are there, you cannot have the measurements from satellites because clouds will hindrance your measurements. So similarly, ground systems also, you cannot make vertical profiles even by using the mobile platform if the clear atmosphere is not clear. So both are having limitations, their own in getting the vertical profiles. So both are interdependent. That's what I wanted to emphasize here. Without that, and modelers are always required for guiding the experiment list. Experiment lists are required for the modelers. That's my answer to that question. Any other question, madam?
No, sir. Only one question is there.
Only one question.
Yeah.
Thank you
so
very
much, sir.
So my email ID is available. You
Yes,
are
sir.
most welcome. So you can put any question anytime. I can.
Okay, sir. Thank you
Pleasure,
so
with
much.
pleasure. Thank you very much.
Moving on, it's an honor to introduce our third speaker of the session, last speaker, Dr. Anup Verma, Associate Professor and Head, School of Energy and Environment, Thapa Institute of Engineering and Technology. Dr. Verma is working as an Associate Professor at School of Energy and Environment, Thapa Institute of Engineering. He completed his BTech Engineering in 2000 and MTech in 2004 and PhD degree in 2014. He has executed various R&D projects in the area of wastewater treatment using advanced oxidation processes. His research group is actively involved in designing solar reactors employing dual effect of photocatalysis and photophantom for the treatment of real industry effluents. He has been executing research collaborations with foreign universities in terms of joint PhD supervision, joint publications, and research projects. His research areas are advanced oxidation technologies using novel composite materials, pilot-scale solar reactors for water treatment disinfection, eco-sanitation, and solid waste management. Sir, today we are honored to have you with us, and before we move ahead, as a part of Amity University tradition, we would like to facilitate you with a virtual Tulsi sapling as a symbol of love, respect, and gratitude. Sir, I request you to kindly accept it. Thank you, sir. Over to you.
I would like to inform everyone that because of certain difficulties, our last speaker is not able to join us for today. And following this, I request each of our speakers from all the domains to please join us for the validatory session, which will start at 4 p.m. because we have the feedback assessment as well in that. So we would like to have your feedbacks over the entire session. Following this, I would request Dr. Charu to please proceed with the vote of thanks.
Thank you, ma'am. On behalf of the entire organizing committee, as I stand before you to extend my heartfelt gratitude and deliver a vote of thanks for this remarkable plenary session. I would like to express my deepest appreciation to our distinguished speakers and panelists who graced this platform with their invaluable insights. I would like to express heartfelt gratitude to Dr. Gaurav Govardhan, Dr. Vaneet Jishtu, Dr. Manoj Garg, and Professor Panuganti C.S. Devra for their thought-provoking presentations. We are truly grateful for your exceptional contributions and the meaningful impact in today's session you have made. My special thanks go to all the members of the organizing committee and attendees for their active participation and making this session a successful one. Thank you.
I would like to inform that we would be closing the session for now. The online assessment form would be active for the next 15 minutes more. So please kindly fill it up and submit soon so that the generation of certificate is not hampered further. Charu, let's close the session for now. Okay.
Okay, ma'am. Thank you.
Okay. It's a lunch break. Let's join us again at 4 p.m. for the valedictory. Thank you.
Thank you.
Session.
Okay, ma'am. Ladies and gentlemen, esteemed participants and distinguished guests, with the blessings of Honorable Founder President Dr. Ashok Chauhan and Honorable Chancellor Dr. Atul Chauhan, and under the guidance of Vice Chancellor Ma'am Dr. Balvinder Shukla, our mentor of AIES Dr. D.K. Bandyopadhyay, and Natural Resources and Environmental Sciences domain, in association with the Amity Academic Staff College, we gather here today to celebrate the successful completion of our 5-day faculty development program on building a sustainable future with green technology, innovations, opportunity, and challenges. This valedictory session marks the culmination of an intensive journey of learning, growth, and collaboration. Throughout this program, we have witnessed the unwavering dedication and commitment of each participant, and today we come together to acknowledge and honor your achievements. As you return to your respective institutions, remember that you have the power to shape the future of education and make lasting impact on the life of your students. To begin with, I would like our team to start with the Saraswati Vandana.
मुनियों ने समझी है गुणियों ने जानी, वेदों की भाषा पुराणों की वाणी। मुनियों ने समझी है गुणियों ने जानी, वेदों की भाषा पुराणों की वाणी। हम भी तो समझे, हम भी तो जाने, विद्या का हमको अधिकार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ।
Thank you so much for sharing this. Now I would request our joint coordinator, Dr. Renu Dhupar, to start with the welcome address.
Thank you, Dr. Joy, for introducing me. A very good afternoon and namaskar to all. I, Dr. Renu Dhupar, extend my warm welcome on behalf of Natural Resource and Environmental Science Domain, Amethi University, Noida, Uttar Pradesh, to greet and welcome to our honorable chief guest of honor, speakers, dignitaries, participants, my dear colleagues and staff members to the valedictory session of 5 days faculty development program. It gives me immense pleasure to stand before you today and address this extreme gathering. Thank you all for taking out time and being present at this important event. Over the past few days, we have come together as a community of educators, researchers, and professionals, and united by our shared passion for teaching and learning. This 5 days faculty development program has been an enriching experience, providing a platform for us to exchange our ideas, explore new pedagogical approaches, and enhance our knowledge and skills. During this program, we have delved into various topics and areas of expertise, ranging from innovative teaching methodologies to emerging trends in research. We have engaged in fruitful discussions, attending insight lectures, and learned from the experience and expertise of our distinguished resource persons, and also from the hands-on training given by our various resource persons during various sessions. It has been a truly transformative journey, which equipped with us new tools and perspectives to excel in our roles as educators. As we gather here today and mark the communication of this program, let us take a moment to reflect on the knowledge we have gained, the connections we have formed, and the growth we have experienced. Each one of us has contributed to the collective learning, sharing insights, and best practice that will no doubt enrich our respective institutions and, most important, benefits our faculties. On this occasion, it is our honor and privilege for us to honor our Honorable Founder President, Sir Dr. Ashok Kumar Chauhanji. And today we are able to conduct this 5 days faculty development program only because of his constant moral support, blessing, and strength. He's a guiding force for us. And your presence, sir, is indeed a great source of motivation. My deep regards and thanks to respected Chancellor, Sir Dr. Atul Chauhan, sir. It is his vision and leadership that has placed Amethi University among the top universities in the world. I am delighted to welcome our respected Vice Chancellor, Madam Professor Balvinder Shukla, ma'am. She is a guiding force for us, and with her support, motivation, and inspiration, we are able to successfully complete this 5 days faculty development program. She is an excellent administrator who leads by example, who polishes each one of us and leads us towards excellence. I extend my warm welcome and regards to our eminent chief guest, respected Dr. Manoj Kumar Pataria, advisor and scientist, Science and Engineering Research Council, for joining us and taking out time to share his thoughts with us in Amethi University. I thank you, sir, for accepting our invitation from a busy schedule. A very warm welcome to you, sir. It is my pleasure to welcome our today valedictory guest of honor, Dr. Arvind Kumar, President and founder of India Water Foundation. The presence of such a personality in a valedictory function is a blessing. And we hope that the participants are able to seek a little guidance and imbibe something from their thoughts. My warm greetings and welcome to Professor D.K. Bandopadhyay, sir, Chief Advisor, Founder, President Office, and Chairperson of Amethi Law School and mentor of Natural Resource Environmental Science Domain. For his continuous guidance and motivation always, I'm thankful for your kind support, guidance, and suggestion given to us and when we require. Thank you, sir. I would like to welcome Professor S.P. Singh, sir, and Professor Tanu Jindal, ma'am, for their endless support and help to execute this event. I would like to express my deep gratitude to our resource persons who have generously shared their expertise and wisdom with us on this 5-day faculty development program. Their guidance and mentorship have been invaluable in shaping our understanding of the subjects discussed in this platform and inspiring us to push the boundaries of our own teaching practices. We are immensely grateful for their contribution and for their dedication to the field of education. I would also like to acknowledge the efforts of our organizing committee, whose meticulous planning and execution have made this faculty development program a resounding success. Their hard work behind the scenes ensured that everything ran smoothly and allowing us to focus on the learning experience. To my fellow participants, I applaud each and every one of you for your active engagement and enthusiasm throughout this program. Your passion for continuous learning and improvement is commendable. I encourage you to take the knowledge and skills you have acquired here and implement them in your classrooms and institutions, and making a positive impact on the educational landscape. As we bid farewell to this faculty development program, let us carry with the spirit of collaboration, innovation, and lifelong learning. Let us continue to explore new frontiers, adapt to changing educational landscapes, and strive for the excellence in our teaching practices. By doing so, we can create dynamic and transformative learning environment for our students and preparing them to succeed in ever-evolving world and adopt the sustainable management practices. I extend my heartfelt congratulations to all the participants for their active involvement and dedication toward this program. May you continue to grow, inspire, and make a difference in the lives of your students. Thank you all for being a part of this wonderful journey, and I wish you the very best in your future endeavors, and please enjoy the valedictory functions. Thank you. Over to Dr. Juhi Gupta.
Thank you, ma'am. Now to begin with, I will just brief about the entire FDP report, which we have done throughout these 5 days program. So over the past 5 days, our FDP has aimed to provide a platform for professional development, knowledge enhancement, and the exchange of innovative ideas. Through a comprehensive curriculum, interactive sessions, and engaging discussions, we have strived to empower you with the skills and insights necessary to thrive in your respective academic pursuits. This program has been carefully designed to cater to the evolving needs of educators and researchers, equipping you with the tools to adapt to the ever-changing landscape of higher education. So to begin with, the day one started with the Saraswati Vandana. We had the welcome note address by Dr. Amrina Khan and the introduction by Dr. Renu Dhupar, our joint coordinator. Then the opening remarks were given by Dr. S.P. Singh sir and our Professor Tanu Jindal, Group Additional Pro Vice Chancellor R&D. Then the address was given by Dr. D.K. Bandyopadhyay, our mentor for AIES. Address by the then our further address were given by our guest of honor. There were 3 guests of honor for the first day: Dr. Brijesh Kumar Yadav, Mr. Shailendra Singh, and Captain Manju Minhas. Following this, the afternoon session continued with the theme, The Green Tech Revolution, Pathways to Sustainability and Innovation. The first lecture was given by Dr. Chirashri Ghosh on air pollution mitigation by green infrastructure. Next speaker was Dr. B.P. Sharma, who told us about quality management systems and sustainability approaches. This marked the end for the first day. Followed by this, the next session for day 2 was held by AIFW, that is MET Institute of Forestry and Wildlife. The theme was Role of Modern Genomic Tools in Wildlife Conservation to Meet the Goal of Sustainable Development. There were lectures based on different themes, including level of inbreeding and depression among Phenoscandia wolves. Apart from this, there were lectures on mechanism of allopatric speciation on Tranogan. This brings us to day 3. The theme was Recent Innovation in Geospatial Technology for Sustainable Future. This was hosted by AIGRIS, that is our Remote Sensing Institute. The first speaker for the day was Dr. Suraj Kumar Singh. He told us about understanding climate change induced vulnerability and risk in the agriculture sector of Kashmir Valley. Followed by our next speaker, Mr. Ritesh Kumar. He told us about introduction to WebGIS and real-time application of remote sensing. Our third speaker for the day was Dr. Shruti Kanga. She told us about human elephant and its coexistence. Then our next speaker was Dr. Vikram Ranga. He told us about geospatial technologies and tools for our sustainable future. This brings us to the afternoon session for day 3, which was held by Dr. Thota Shivsankar. He told us about exploring the role of Google Earth Engine in sustainable agriculture and land management. He also told us about a software from the GIS domain and gave us a hands-on training for the same. This was followed by a documentary film. This brings us to the end of day 3. Then the day 4 began with the theme green technologies and sustainable development. This was begin with the first speaker, Dr. Bibu Prasad Rath. The topic was innovation in green technology. The second speaker was Dr. PC Mathani on the topic energy, climate change, and sustainable future. The third speaker was Dr. Manohar Alam Khalid. Topic was science and environmental sustainability and the way forward. This brings us to the afternoon session, which was started by the first speaker, Dr. Shalini Sharma. She spoke about building energy, current techniques in energy and its efficiency. Then the next speaker was Dr. Anisha Bajpai. She told us about climate change mitigation through sustainable, restorative, regenerative building designs. And the last speaker was Dr. Madhurima Wangmare. The topic was demystifying use of green technologies for resilient cities and communities. This brings us to the day 5, which was started by AIES, and the theme was combating technological challenges to decode a green tomorrow. It started with our first speaker, Dr. Gaurav Govardhan. He told us about the decision support system for air quality management. It's a tool in a sustainable world. Then our next speaker was Dr. Vaneet Jishtu. He told us about the nature, role, and value of the Western Himalayan temperate arboretum as a green space for Shimla. Then the third speaker was Dr. Manoj Chandra Garg. He told us about AAS and other instrumentation techniques. This completed our last plenary session, and the vote of thanks was given by Dr. Charu. Now, I would like to give you a glimpse about the entire session through a small video. Is my screen visible, everyone?
Yes.
Okay.
Start its audio, Dr. Juhi,
Yes, sir.
and make it a full screen mode. Audio, Dr. Juhi. It's not audible.
Ma'am, any audio
It's
in
not
this video?
audible?
No, ma'am.
No.
Please reshare your screen with. Hello, ma'am. Please reshare your
Yes, sir.
screen. With
Reshare
select.
my screen.
Yes, ma'am. With select share sound button.
Just a second.
Please reshare, ma'am.
I will.
Select share sound button.
Yes, sir, I'll do.
नहीं HBCU थोड़ी है बात करेंगे
First one.
क्या है ये Dr. Juhi, again, it is not audible. Now it's audible.
So this was the glimpse for the entire session, and obviously with a small motto at the last, that we have seen that we have begun with a very good green infrastructure. Then we have started pacing towards a very developing world, which is leaving the nature behind somehow. So which is why we need to cope up again, or else we will be lasting towards a world which is completely full of waste, which was indicated at the last of the video. So which is why I ended it with the motto that time is now to change, or else it's your choice to begin at what particular position, or else it'll be really late. So this brings me to invite our next Professor Tanu Jindal, Group Additional Pro Vice Chancellor R&D, MET University Uttar Pradesh, to please address all of us. Tanu ma'am. I can see her in the participants.
टेलीफोन कर ले, रेनू टेलीफोन कर ले, अनामिका.
Okay, sir.
Yes, sir.
I'm really sorry, till the time ma'am joins us, I would request SP Singh sir, our director ASNRSD. He has joined us. So I would like sir to please give us the closing remarks. SP Singh sir, are you here? Yes, sir is here. Sir, please.
Yes, sir. I just joined.
Yes, sir.
Good afternoon to everybody, Dr. Bandyopadhyay sir and all esteemed colleagues of this organization. The only, in very short, I would like to say it's a wonderful, excellent, good teamwork arranging this kind of FDTP, this FD program, faculty development programs. And I was continuously monitoring through Dr. Lalita Pradhan that almost all resource persons attended this and gave a very excellent presentation on various wide subjects. And there was also a good interaction with the participants that really motivate all of us, and also give a good impression to the resource person that participants are listening and interacting with them. It is a way of how we can improve our system and how we can get day-to-day more informations, more knowledge on the subjects. I think the only thing we should keep on encouraging, and we should also try to do all the time better than this. This is an excellent, but there is always a chance to improve it upon. And now we also see that we are calling people from outside. We should also try next time that we have a number of resource persons available in different MIT universities, different places, so that we should also get interaction with them. And although at the same time, if we involve them also as resource person, then likely we can add more participants on these areas. In short, I congratulate all the teams, all the faculty, Renu Duperts and her teams, Lalita, Dr. Maya, Randeep Singh, that they all done work under our able guidance of Dr. D.K. Bandyopadhyay sir, and the continuous supports from our Honorable Vice Chancellor. With these words, my congratulations and best wishes, all of you. Thank you very much.
Thank you so much, sir, for all the wishes and congratulating all of us. This brings me to Dr. Tanu Jindal. Ma'am, have you joined?
So I really congratulate for organizing this 5 days FDP, and I have gone through the program and the themes session. They are very, very relevant, in fact. And I would say that, I was trying to list many technologies which are, green and clean and also circular in nature. But the awareness and the thought process to adopt all these is very much required. And I have been emphasizing on, involvement of United Nations in it. So that if United Nations can list the technologies in every sector, be it consumer goods, be it electronics, be it aviation, be it cars, be it automobiles, be it energy production, you name the sector. So there are many new innovative technologies have come nowadays, which should be listed and promoted globally. And at the same time, business houses, business systems must look into eco-friendly technologies, even though they are giving less benefit or less revenue, but for the sake of the planet, for the globe, under corporate social responsibility, they should take some more projects besides the product. But under CSR, they can, like, yes, in my talk, I spoke about Indigo Airlines, I spoke about other aviation airlines, which are taking small projects, which are like reviving of a pond, or, having community STP plants, community having a plantation drive, right? Having a solid waste management. So there are, likewise, there are initiatives which we all need to adopt at our level. There are two kinds of movement. One, the mass movement. Masses has to be aware about their responsibility for green technologies or circular economy. Like, buy two, get four culture. We need to forget that if you are getting in two, you're getting four things, you don't need them, So this is a consumerism. Just to abolish this consumerism, we need to really change our thought process. How we, can be minimalistic, simple living, high thinking, which we used to say in ancient times, simple living, high thinking. I think this slogan has to be adopted again, and then only we can give this world a safe planet. Because more we need, more production, more pollution. There are two things. One is polluting things. Second is amount. Third is green technology and clean technology, renewable technologies. So we need to have a combination of all of these. So a list has to be issued at national and global level, because whosoever devices a green technology, we have to come together to buy that technology. Like I spoke about refrigeration. There is a new method of refrigeration which does not use CFCs. So it has to come globally. If some countries are using, some countries are not using. Anyways, they are usually emitting, freons or free radical chemicals, which further, abolish our ozone layer. So it has to be a mass movement. It has to be a policy decision, both to have a circular economy and green technologies to save this planet. And I am really, again, thankful for organizers for inviting me in the valedictory. And thank you and all the best for conducting such wonderful 5 days FDP program. Thank you.
Thank you so much, ma'am. And we definitely agree that this has to be a mass movement to make certain changes in the environment. Now I would like to request our Professor D.K. Bandhopadhyay, sir, Chief Advisor FPO, Chairman, MET Law School, and Mentor, MET Institute of Environmental Sciences, to please address all of us.
So thank you, Joy. Thank you very much. Now, really, it is very splendid that in the hot summer, I must tell it, in the hot summer, when the climate is not at all conducive for anybody, whether we stay at home or stay in the office or stay in the classroom, because we have created that type of situations. Now, under this such type of situation, what do we do? Now, unless and until we collectively and as a humanity work towards looking at our natural resources from a different perspective, and that perspective should be such that it is not only going to be sustainable, but also going to grab the developmental perspective, because population is increasing, there will be demand of the natural resources, because we know that for meeting up the requirement of the humankind or mankind, the natural resources are being utilized, and they are bound to be utilized. Having said so, this 5 days program, the way it has been designed, and I'm very happy to see that they're starting with the introduction to green technology and sustainability. What is the relationship between the green technology and the sustainability? That itself shows us the clarity as an institution, that what sort of clarity we have got within our mind, so that we can impart this, skill and knowledge to the participant, those who have joined this, faculty development program. Now, what are the different types of innovations in the green technology that has come? And the need of the green technology, we have already discussed it in the inaugural session, and the coming 5 days, they all discussed about the different types of, green technology and its innovations. And then, that is it that green technology is going to take away many jobs? Is the green technology is going to provide us not only the better living, but also it is providing us the opportunities of creating new jobs? That means economic aspects. What sorts of new opportunities that are going to come up? And for doing that, what should be the policy intervention or the policy considerations? And that is mostly important thing, because we have to see the best practices that are coming up from elsewhere, successful policy and regulatory approaches, and followed by that as environment cut across boundaries, it does not believe in sovereignty. It is believe of the global village. So under that type of circumstances, we have to see that what is the best way we can collaborate, cooperate, and then provide us our future look. And that to me is the most important thing. At the end of the day, in this 5 days program, if we are able to establish that fact, that if we want to live in this planet, there is no other way but to look for these alternatives. The way we have been living, the way we are actually creating our own, for the creation of our own comfort, the way we have utilized recklessly the natural resources. Now, what is going to be the change in the pattern? What should the right type of policy to be put in place so that this type of damage can be reduced to? Now, so different tools and techniques of research in those directions, new technological research, new way of making the policies. What should be the different types of policy interventions are needed for that? What are the different types of global challenges that are before us? And what is that the faculty members, those who are attending this program, they themselves can do and think of spreading it, spreading the awareness to the grassroots. Most important thing is the grassroots level in terms of changing their lifestyle, because all of us know that, unfortunately, if we look at our our living, and it has two costs. And all the time I say that in different forums, I am also discussing about it. There one is our living cost, another is our lifestyle cost. These are the two costs for our survival. But living cost, if we just take into consideration that if you are really satisfied with a small type of living, where we have got a bedroom to sleep, We have a kitchen to eat, to prepare the food. We have a place where guests can come and sit over there. More than that, we do not need anything. So that living cost, and then in the cost of the food that we take it, if we just take those into consideration, then we roti kapda makan, and it is not substantial. It is very, very less. But then what actually killing us in terms of maintaining the lifestyle cost? And the lifestyle cost creates more and more greed to us. Today, I've got a small car, I must have a big car. I have a small fridge, I have a big fridge. I have got one air conditioner in one room, I must have 3 air conditioners in my 3 room. I have got a 1 room, I must have a 4 room. And I must have a bungalow. I may be traveling singly alone in a car, but I will be having 10-seater car with me. This type of lifestyle costs is enormous, and there is no end of it. So now the time has come, the people must think that, how this can be reduced to, and for running them, what sort of, resources that should be taken from the Mother Earth or Mother Planet, that we can replenish them, if not fully, but substantially. Like say all the time we are talking about, we use water, but don't misuse the water. And whatever water will be left, try to see that it gets recycled. Whatever water you use, just try to see that how best it can be put in place for further uses of it. So this type of thought processes, this type of new technology that has come. Similarly, irrigation, if you just look at, now do you need such type of irrigation? What we do, what we practice? Now Israel has seen great success of deep irrigations and the minimal requirement of the water for the production of the food grains. Now all those best practices, we have to bring it, and then we'll be able to save our planet. Otherwise, very rightly the film that has shown that if you do not go green, and we use the green technology, then I think nobody is going to save the planet. Already there is a danger, and everywhere we are finding there is a tremendous amount of change in the climate. Now, under that circumstances, this FDP was very apt and was, has given the different types of, insight. Now, what are the different scopes for innovation for the faculty? What are the different opportunities that lie for the students? And what about the challenges that actually at present we are facing, and in a very articulative way by different eminent speakers. Now, in other words, building a sustainable future with green technology, not only essential for mitigating environmental challenges, but also fostering economic and social well-being. By embracing innovations in renewable energy, energy storage, circular economy, and digital integration, societies can reduce their environmental impact and promote sustainable economic growth. However, overcoming challenges related to cost, infrastructure, and policy framework is crucial to realizing the full potential of green technology. By addressing these challenges and leveraging this opportunity, we can create a more sustainable, resilient future for the generation to come. And that is a conclusion theme that has brought through this, FDP. Now, so many speakers have come, and as a mentor of these institutions, I feel privileged to thank them, to show our gratitude to them that they came along and actually gave their thoughts, their expertise to the faculty member, so that there could be appropriate fusion that would take place, so that there is a discharge in our mindset that what should be done. Now today, even at the end, I see that very two eminent persons that they have spared their time to come over here. I cannot, but on behalf of the entire MIT universe, especially on behalf of our Honorable Founder, President, and Chancellor, Dr. Atul K. Chauhan, and who has given us this great university to talk about the different facets of environmental happenings and mitigating the environmental happenings. And on behalf of them, not only I thank to those who already spoke, those who came, delivered the lectures, but also today's guests, Dr. Arvind Kumarji, President and founder of India Water Foundation, and chief guest of today, Dr. Manoj Kumar Pataria ji, advisor and scientist ji, Science and Engineering Council Research. Really, sir, on behalf, we are really thankful to you. And as I mentioned, on behalf of the entire Amity universe, I express my gratitude to both of you. I express my thankfulness to both of you that you could spare some time. And hopefully, in the future, our relationship, our collaboration, that's one of the theme of the FDP was, our collaborations will essentially try to address some of the challenging issues and also creating the better opportunity for our next generation or for our next future generation, so that they will not blame us that you, the generation, you have created such a havoc that it has become very, very difficult for us to survive. That should not happen. Now, very rightly, all those conventions has been addressing it. All the world leaders are coming together and actually discussing this hot topic. Every seminar, every conference you go today, everybody talks about the environment, everybody talks about climate change, everybody talks about the high temperature growth. Everybody is talking about that. So, and Amity Institute of Environmental Studies, and I feel all the time they try to do something which others have not done it. And now and then, every week, I talk to Dr. Renu Dupar. Every week I find something or other they are doing it. I say it's okay. It's very good because the vibrancies will be there. And then if we discuss 100 things, if at least 20% or 30% go in the mind of the faculty members or the students, then that would be a great benefit. So every program, if we can reach to 20 to 30% of the input that are being given by the different external speakers, if it can get percolated, that means we'll be able to see different dimensions and different types of approaches to that. So thank you, Renu, for carrying out the responsibility. Thank you, Vanamika. Thank you, Jui, and Maya Kumari, Professor S.P. Singh. And you are all the time supporting them. Really, I am thankful to you, and thankful to Dr. Tonu Jindal, who created this institution, and now she has taken higher responsibilities, and that indicates that the type of efforts and energy she put, and the type of faculty member she groomed. Now, she should feel proud that they have now started giving the different types of orientation to these institutions. So thank you very much. Thank you, everybody.
Thank you.
Thank you so much, sir. Very rightly said that environment has sufficient for our need, but never for our greed. With these words, I would like to invite our guest of honor, Dr. Arvind Kumar. And Dr. Arvind Kumar is the president and founder of India Water Foundation, a non-profit organization and a think tank with several accreditations. He's a strategist and key influencer in the developmental sector with more than 28 years of experience. He's an author, columnist, water activist, and specializes in ecosystem-based adaptation, water, energy, food nexus, and SDGs. He has published more than 500 research articles and is author and editor of several books and journals. He's the former member of National Wetlands Committee, GOI, member Technical Advisory Committee for India's third National Communication and Biennial Update Reports to UNFCCC, member of the Meghalaya State Water Resource Council and Meghalaya Council for Climate Change and Sustainable Development. And as per our tradition, we would like to welcome you, sir, with a virtual Tulsi sapling. Our mentor, Professor D.K. Bandyopadhyay, sir, is presenting you the sapling, sir. Please accept it. Thank you, sir. I would now like to request you to please address all of us.
Professor Shukla, Professor Bandyopadhyay, Dr. Manoj Pataria, faculty members, students, and online audience. A very good afternoon to all of you. At the outset, I thank the organizers for inviting me to this event. The role of science and technology in building sustainability is becoming a topic that is being discussed across the world. With the resources steadily exhausting, the importance of science being able to find a solution has become even more compulsory now. The role of science technology is building sustainability development to fight against the challenges posed by man-made climate change, pollution, and other challenges is truly imperative at this stage. I'm sure in the 5 day, there are very good discussion on a range of topics related to technology. I also see the video. And especially green technology, due to the increasing global population, levels of natural resource degradation are also increasing. This has resulted in the estimation of world's eco-footprint to be 1.5 times the ability of Earth to sustainably provide each individual with enough resources that meet their consumption levels. Achieving sustainable patterns of the consumption and production is critical if we are to overcome the triple planetary crisis of climate change, biodiversity loss, and the pollution waste. This requires a fundamental transformation in our economies and societies. One that puts human well-being and the ability to all people to thrive as its main objective, and it's underpinned by the resource efficient, low carbon, low polluting consumption production patterns. Since the Industrial Revolution, large-scale mineral and oil exploration has been increasing, causing more and more natural oil mineral depletion, negative impact of technology on the environment caused by industrialization, rapid industrialization. Many believe that new environmental technologies such as renewable energy combined with the smart logistics and electric transport has the potential to bring about the rapid decarbonization of our economy and the mitigation of further detrimental harm, combined with the achievements in technology and development and research and exploration of minerals has become easier, and humans are therefore digging deeper to access more, which has led to many resources entering into a production decline. Moreover, the consequences of deforestation has been more severe, with the World Bank reporting that the net loss of global forest between 1990 and 2020 was 1.5 million kilometers square. This is primarily for agriculture reasons, but also logging for fuel and making space for residential areas. Encouraged by increasing population pressure, not only does this result in the loss of trees, which are important as they remove carbon dioxide from the atmosphere, but thousands of plants and animals lost their natural habitats and have become extinct. Technology play a very vital role in sustainable development, whether it's social, economical, or environmental. The role of technology to meet the requirement for the sustainable development cannot be denied. There is great reluctance among governments and others to create political and social changes that are necessary to decrease the growth in production and consumption. There is where the dependence of science and technology come into play. Most countries are now using science technology to identify the answers to achieving a sustainable future, solving the environmental problems that are facing. Sustainable industry catchword is the imperative for well-being. If we look at India's contribution in global sustainability mission, the country has taken great strides to achieve its sustainability goals. At the COP26, the Prime Minister Narendra Modi committed that India would achieve its net zero carbon emission target by 2070 and will need 50% of its energy requirements from renewable sources by 2030. Almost 30% was 50%. To achieve our sustainability goal, we need to invest in disruptive practices. India has taken great leaps in terms of green energy practice, it is one of the few large countries that have done exceptionally well in terms of saying truly aligned to commitments and made in the Paris Agreement. The country's economy is growing and provide a great opportunity to follow the path of sustainable development through innovative solutions. Today, the government is investing in systems to reduce the carbon footprint. On its part, the industry is adopting practices for a transition in net zero. The country is transforming its road traffic to electric, lowering dependence on fossil fuels, cutting imports, and has set a target to achieving of at least 500 gigawatt by 2030 from renewable energy. Green energy practices have a great potential to attract investments and can bring in funds to transform ideas into actions. Energy efficient equipment and large tech adaptation are must have for sustainable future. A simple yet massive campaign for adoption of LED bulbs is reducing India's emission by 40 million tons annually. Huge. I am personally delighted to see that everybody is getting environmentally conscious and making every possible effort to take care of our planet. The focus of business is shifting from making profit to adding value. Take, for instance, the industrialized farming sector. It was a reliable way to produce a lot of food at a reliable low cost, but it's not the bargain. It's once believed to be peak. Unsustainable agriculture can pollute water, air, and soil. Is a source of greenhouse gases and destroys wildlife. All told that cost economies about the 3 trillion every year. And to top it off, some farming practices have been linked to the emergency of zoonotic diseases such as COVID-19. We have to make our food practices sustainable, which not only meet the need of the existing future generations, while also ensuring profitability, environmental health, and socio-economic equity. It favors techniques that emulate nature to preserve soil fertility, prevent water pollution, and protect biodiversity. It is also a way to support the achievement of global objectives like Sustainable Development Goal and Zero Hunger. It ups to 56% less energy per unit of crops produced, creates 64% fewer greenhouse gas emission per hectare, and supports greater levels of biodiversity than conventional farming. Diversity, our diet, eat more plant-based foods, enjoy pulses, peas, beans, and chickpeas as a source of protein. Eat local seasonal foods, avoid excessive packaging, which is likely to end up as a landfill. Eliminating food waste could reduce global carbon emission by 8 to 10%. The industry now have well thought strategy in place for sourcing, allocation, utilization of raw material, fuel, and water for sustainable practice. A zero harm, zero waste, zero discharge approach can be a step forward, transforming industry practice for good through material recovery, reuse. It's important to outline an efficient waste management to prevent the environment from degrading. Adopting innovative methods for full utilization of materials and zero waste can minimize the material use of mitigate environmental challenge. Cities can generate over 80% of GDP in many countries in Asia and Pacific are engines of economic growth that have lifted millions from the poverty. This economic growth is accelerating rural to urban migration. The economic growth is accelerating rural to urban migrations. Asia cities will become home to another 1.1 billion people in next decade as the poor continue to be down to better opportunities. Today, approximately 700 million people in urban slums. Many cities are already struggling with environmental degradation, traffic congestion, inadequate urban infrastructure, and lack of basic services like water supply, sanitation, waste management. Environment footprint of the cities are quite alarming and can threaten the natural resources required to sustain the economic development and poverty elevation rates, maintaining economic growth and while creating sustainable livability for all is the biggest urban challenge facing Asia and the Pacific today. A specific focus is needed on access to housing, basic services, sustainable transport systems, sustainable environment, access to public spaces, sustainable building, per capita environmental impact of cities and policies towards climate change, resource efficiency, and disaster risk reduction. A sustainable city is an urban center engineered by the green technology to improve its environmental impact through urban planning management. For an eco-city definition, picture cities with parks and green spaces, solar-powered buildings, rooftop gardens, and more pedestrians and cycles than cars. This is not a futuristic dream. Smart cities are actively moving towards greening urban ecosystem and better environmental stewardship and green buildings, which are healthy both for the occupants and the environment. They are energy efficient, conserve resources, create healthier indoor environments, and offer durable and beautiful spaces that use environmentally sustainable material. Ultimately, adoption of green building practices could lead to a paradigm shift in the building industry, with the sustainability meticulously imbibed in the practice, products, standards, codes, and the regulation. Every year, humanity produces more than 2 billion tons of the municipal solid waste, of which 45% is not managed in controlled facilities without urgent action. This will raise to nearly 4 billion tons by 2050 waste, including plastic packaging, food cloths, electronics debris from the mining and construction sites, lead to disastrous consumption for human health and economy, and aggravates the triple planetary crisis of climate change, nature, and biodiversity loss and population. It is disappropriately affects the poor, and up to the 4 billion people lack access to proper waste disposal. A deep focus on the circular economy can lead to 100% utilization of wastewater and solid waste. The benefit of zero waste include clean seas, fresh air, fertile soils, and sanitary cities, and resilient economies and sustainable extraction. This is a key component of circularity, which is concept that the potential wasted product generates by the end of its life is considered at the point of manufacture. A circular economy involves the reduction and minimization of the waste through product life cycle. Zero waste is about redesigning and our systems and changing our habits so that all resources are used sustainably. We aim to leave a clean, developed, and livable world to future generations. A circular economy carries the potential of integrating regenerative design thinking and efficient use of resources. This also increases the potential to economic growth, open new opportunities. Focusing on circular economy can initiate action on reduce, reuse, recycle for action-based solution for sustainability. I am also looking forward to recommendations that have come out all the 5-day deliberation, even I saw, and discussion, and congratulations ability for a timely intervention on such a crucial topic. In fact, the World Environment Day is coming again with a theme of beating plastic pollution. Is a reminder to translate commitments into actions to protect the environment and reiterate our responsibility towards the cause. The window for transformative change is narrowing, but it is still open. The choices we make now will define the planet health, not just for the next generation, but for many generations to come. Thank you very much for giving me this opportunity. Thank you very much.
Thank you so much, sir, for addressing us so efficiently and also for highlighting about the net zero goal and even the changing statistics. I'm sure that foundation like yours and others is definitely going to help the changing climate and would surely make a change. Your suggestion to incorporate the waste management, the better water usage in our daily lives is also very highly appreciated. Thank you so much, sir. With this, I would like to invite our next speaker. Our next speaker is our chief guest for this entire session is Dr. Manoj Kumar Pataria. He is the former advisor and scientist G for Science and Engineering Council Research. I would like to introduce you, sir, first. Professor Dr. Manoj Kumar Pataria has been the former advisor and scientist G for Science Engineering Research Council, Department of Science and Technology, DST, Government of India. He's also responsible for promoting scientific research and innovation in the country. In his prior assignment, he has served as Director, CSIR, National Institute of Science Communication and Information Resources, and he has also taken a number of initiatives for the same. He is decorated with prestigious national and international awards. He has a number of publications and 2 Indian patents to his credit. He has authored, edited, and co-edited widely acclaimed books like Genes Write the Story, Sharing Science, and Science Meets Communication. He is the president of the Society for Information Science and founding fellow of the Academy of Engineering and Technology of the Developing World under aegis of UNESCO. He has been elected as the chair of International AASSA Special Committee on Shared Communication, that is recognition of positioning India at global level in the area of science and communication. We welcome you, sir, and I would like to present the virtual Tulsi sapling. Our Vice Chancellor, Professor Balvinder Shukla, Vice Chancellor welcome you from all of us. Please address all of us. Thank you.
Thank you so much. Very good evening to all of you.
Good evening, sir.
Good evening, sir.
Bandhopadhyay ji, Dr. Tanu Jindal, Dr. Arvind Kumar ji, all distinguished faculty members, officials, and dear participants. I am delighted to be part of this wonderful program that you have been participating for last 5 days or so. And I feel that may be very informative and very useful for all of you, and eventually for the students whom you are going to teach. I also learned a lot, number of things where new avenues are opening up and how we can really cope up with the emerging threats and challenges of climate change, and how green technologies and green endeavors can really bring in certain changes for sustainable development. I appreciate the presentations which were made in 5 days as per the report, and congratulate MET entire university, its chairman, all officials, and the entire staff, and all those who have organized and put together this wonderful program. I would like to share some of my essay thoughts, although many of you must be feeling so tired to leave early, but I will take some time for sharing some of my essay thoughts on this very important area. When I say that this green technology and how we can really bring in the changes, because we are responsible for spoiling, in fact, our environment for last couple of decades or so. Prior to that, we have been an austerity society, and we have been very happy in minuscule things around us. It is only the market-driven forces and the greed, as Dr. Bandhopadhyay has rightly said, of the people around, bring in all the miseries for all of us. And that is coming from all around. Not only in India, but other countries are also facing the threats of these changes, which we have brought in over the period. I would like to cite some of the examples that I came across recently. I was attending a program somewhere in Gulf countries, and I simply noticed that the use of tissue paper was extreme. They were using for anything and everything for this tissue paper. And as a matter of fact, all of us, we know that how this tissue paper is produced. At one end, the trees are cut, best quality trees are cut, and paper is produced. So how about, instead of using this tissue paper, we can use the handkerchief. So I simply shared this simple thought in my address in that country. And next day it was the headline. And to my surprise, before the end of the program, all tissue papers were vanished from the entire premises where I was addressing the people. So this is a small change that I was able to, I was instrumental in bringing this that change in that country. I don't know what happened after that. So this is a small thing that we can do. What government can do, what UNO can do, what states can do, that is a different story. What companies can do, but what we can do, that makes a lot of sense. Similarly, we are suffering yet another problem in our country. Overcooling, over-chilling. This is extreme summer. And I would like to happily share with you, I am sitting here in my room comfortably without using AC. And I have not yet started my air conditioner, even in the night. I only enhanced the speed of my fan. Earlier I was using at 1, then say in April I used 2, now it is working on 3 comfortably. No need of AC for me. As a matter of fact, India is at the highest level of the patients suffering from pneumonia. Pneumonia-borne deaths are increasing in countries like India. And the main cause behind this is over-chilling. Over-chilling causes number of problems, ranging from pneumonia to heart attacks and so many things. So I have seen in countries like Indonesia that the temperature is set. If you sit in the taxi, the temperature would be, you will feel like 28. You will not feel like 16. Here in our country, we put the air conditioner at 16 and we'll use the blanket and we'll be very happy for going for sleep. So these are the simple things, how we are experiencing in our country and how we can really bring in certain changes. एक मैं बताऊं, हमारे पास हम लोग जो है पजामा बनवाते थे, पजामा फट जाता था तो उसका हाफ पैंट बन जाता था, वो फट जाता था तो उसका पोछा बन जाता था. So this is how we have been leading our lives. Still now I am using these bits and bits for saving the environment. एक और मैंने कोशिश करी है, एक शादियों वगैरह में जो invitations आते हैं. Nowadays we are receiving after Corona mostly digital invites, but generally it comes in the envelope. And as a contrast, we go to market, and market has given us very interesting envelope. एक दे दिया है जो 10 रुपए से लेकर के 100-200 रुपए तक का आता है, उसमें 1 रुपए का सिक्का लगा होता है. And we put some money and happily hand it over to our host who has invited us, bride or groom or whosoever, or their parents. मैंने थोड़ा सा एक हम्बल प्रयास किया है कि जिस एनवेलप में इनवाइट आता है वो भी बेकार हो जाता है, तो उसी एनवेलप में हम वो पैसे रख करके उनको देंगे और उसमें एक स्टैंप लगाएंगे कि to save environment I am using the same envelope, please don't mind. मैं 100 रुपए या 10 रुपए नहीं बचा रहा हूँ, बल्कि मैं एनवायरनमेंट को बचा रहा हूँ. एक एनवेलप जो आप मार्केट से लेकर के उसमें सगुन का जो देते हैं, so that will save our environment. कम पेड़ कटेंगे, कम कागज बनेगा और हमारा ग्रीन जो सराउंडिंग्स है वो बनी रहेगी. So through all these 2-3 examples, I wanted to share some of my thoughts that how small things can really bring in bigger changes and how we can really save our environment. And moreover, एक और मुझे बात आती है अभी एग्रीकल्चर की किसी ने बात करी. When I happen to be in DD Kisan channel, and I am happy to share with you that 8 years before, today on 26th of May in 2015, Honorable Prime Minister has launched the DD Kisan channel, and I was the first head of that channel. So I was very busy 8 years back today, when 26th of May it was launched. When we were launching this Kisan channel, so because it was targeting the farmers or the farming community, so we entered into a small piece of research. Generally, there is a belief that something like 70% of the population is based on agriculture. So that is a kind of belief that we carry and we write in articles and newspapers and books and whatsoever. But as a matter of fact, when we entered into a small piece of research, we found that 70% is not the farming community, the farming population. 70% is the population that lives in the villages. So village population is 70% or something like 69% or something. We can say around about 70%. But the entire rural population is not agriculture-based population. They are engaged in various other professions also, other livelihood also. So when we went deeper into this research, we found that something like 22% is the farming community, as a contrast of 70% that we have been taught and we have been generally carrying that thought with us. It is not 70%, but something like 21 point something. We can say 21 to 22%. If we go further deeper to that, to our surprise, that number goes to drastically lower. It is only 11% land holding farmers. The rest of that 10 or 11% people are farming labor, those who are working in the farmlands. That is diminishing very fast, very fast. And the reason industrialization, pollution, all these things are happening. और जैसे कहते हैं ना किसान का बेटा किसान नहीं बनना चाहता. Although Kisani is also now a very thriving kind of business. A lot of corporate sector are coming into farming profession, and they are offering very good jobs. So we are more towards getting job, but rather than doing certain things for really greener tomorrow, I think that we need to think twice or thrice, or we have to focus that, so that we can save our diminishing farming community. Because first of all, we need food. सबसे पहले हमें भोजन चाहिए. तो अगर हमारी आबादी किसानों की इस तरह से कम होती जाएगी, and recently the Prime Minister some scheme has come, and under that scheme something like 9%, this 11% to land holding farmers. In that scheme, they have registered only 9% farmers have registered. So now this is coming down to further 9% or 10%. So मोटे तौर पर हम कह सकते हैं कि farming community in this country is something like land holding farmers is only 10%. If we add on the farming labor, it could be something like 20 to 21 or 22%. So that has to be enhanced. इसकी बहुत जरूरत है. अब बात आती है, our farmers have been working for centuries for this organic farming. हमारे पास कंपोस्ट होता था, हमारे पास गोबर होता था, हमारे पास और बहुत सारे साधन होते थे organic farming के. Then the market came and they said, no, you use this chemical. This will enhance your productivity. And what happened? Now we are suffering with number of diseases, number of problems, number of issues. Again, this circle, and they are now teaching us that you go for this organic farming, because the same set of people, the same set of market Now they are telling us you go for organic because they can reap more profit from organic farming. आज उसका पैसा ज्यादा मिलता है मार्केट में as compared to आपका जो chemical जो farming वाला जो product है. So these are the things I think we need to understand. We need to inculcate into the minds of the people. It begins from ourselves. If we start thinking on these lines, these big things, they are coming mostly from the Western countries, the Western thoughts. They have, incidentally, ये क्या है जो US has not signed this environmental treaty, you know, and the most polluting country, the most country is US. सबसे ज़्यादा garbage US पैदा करता है और वेस्टर्न कंट्री सबसे ज्यादा गार्बेज पैदा कर. हम तो अपना गार्बेज कंपोस्ट बना देते थे, हम तो उसकी खाद बना देते थे, उसके दूसरे इस्तेमाल करते थे, लेकिन आज उसी के पीछे चल करके हम ये कर रहे हैं. सो दे आर टीचिंग अस दिस कार्बन फुटप्रिंट कम करो, ये कम करो, ग्रीनर हो जाओ, ग्रीन टेक्नोलॉजी लाओ. द टेक्नोलॉजी दैट abundant there, they are transporting us, they are exporting this technology to us. और फिर हमें वो सारी चीजें सीखनी पड़ती हैं और हम लोग वहां से सीख करके अपने लोगों को सिखाने लग जाते हैं. अभी हाल ही में आई हैव सीन ए वायरल वीडियो दैट हैज कम आउट फ्रॉम समवेयर फ्रॉम ए नीबरिंग स्टेट, फ्रॉम एनसीआर से कहीं से आया है, जिसमें ये बताया जा रहा है कि इंडस्ट्रियल इफ्लुएंस कोई वाटर बॉडी है और वो बहुत सारे इंडस्ट्री है दिल्ली के आसपास एनसीआर में. इंडस्ट्रियल इफ्लुएंस उस वाटर बॉडी में जाकर के डंप कर दिए जा रहे हैं. दैट इज नंबर वन. अब कॉमन सेंस से वन कैन अंडरस्टैंड when you dump these effluents, chemical pollutants, effluents in a water body, then what will happen? This will go to the groundwater. और ग्राउंड वाटर जहां से आप अगर हैंडपंप चलाते हैं या कुआं इस्तेमाल करते हैं या बोरिंग करते हैं या जो भी वाटर सप्लाई आपके यहाँ आती है वो उसमें मिल जाने वाले हैं और मिल ही जाएंगे. सो ये एक बहुत बड़ा खतरा पूरी दिल्ली एनसीआर में आ रहा है कि जो ये बहुत सारे जो इंडस्ट्रीज हैं, इनके जो इफ्लुएंस हैं वो हमारी वाटर बॉडीज में, हमारे जमीन के अंदर उनको डिस्पोज ऑफ किया जा रहा है और वो सीपेज के द्वारा सारा का सारा हमारे वाटर सर्कुलेशन सिस्टम में आ जाने वाला है, हमारे दूसरे और चीजों में आ जाने वाला है. तो ये कैसे आगे काम चलेगा आगे 10 साल में, 5 साल में, 15 साल में. I would also like to cite yet another example. You must have read the decision of Honorable Supreme Court कि जो यमुना पुस्ता है, जो नोएडा और दिल्ली के बीच में जो बैरेज बना हुआ है, वहाँ यमुना पुस्ता में बहुत सारी सब्जियां आपने आते जाते खरीदी होंगी या खरीदते होंगे, कभी गाड़ी रोक करके बहुत सारे लोग खरीदते हुए मिल जाएंगे. वहाँ पुस्ते में सब्जियां उगाई जाती हैं. दैट इज कार्सिनोजेनिक, क्योंकि वो सारा का सारा जो है एफ्लुएंस है यमुना का जो वो है. सुप्रीम कोर्ट ने रोक लगा रखी है, लेकिन वहां पर वो जो उगा रहे हैं सब्जियां, उनको उगानी है, उनको लाइवलीहुड चलाना है, क्योंकि अल्टरनेट नहीं है उनके पास में, कोई रोकने वाला नहीं है. हमारे जैसे बहुत सारे लोग सस्ती सब्जी के चक्कर में या ताजी और अच्छी दिखने वाली चमकदार सब्जी के चक्कर में वहां गाड़ी रोक करके वो सब्जियां लेते हैं. तो मुझे लगता है कि ये जो रोजमर्रा की जिंदगी से जुड़ी हुई ज्यादातर चीजें हैं, इन पर हमें ज्यादा ध्यान देने की जरूरत है. एंड तभी हम इन चीजों पर पार पा पाएंगे. चीजें बहुत सी हैं और करने को बहुत कुछ है, लेकिन जैसा हमारे डॉक्टर अरविंद कुमार जी ने कहा कि अवेयरनेस could be the key for overcoming all the miseries of the people. That is very pertinent, very important. And I would like to say that awareness and communication, especially health communication, agriculture communication, risk communication, environmental communication, that is very, very important. And I'm happy that MET University and your institution has put together this wonderful program and giving us this opportunity for sharing some of our thoughts on this occasion. I wish you all the best and look forward for meeting you sometime again on yet another platform. Thank you. Namaskar.
Thank you.
It's beautiful thoughts.
Thank you, sir.
Beautiful thoughts.
Thank you so much, sir.
Actually, we are already in sync. We are in sync, and
Sir.
let us have the synergization. And our honorable founder president all the time says, when there is a synergy, there is energy. More synergy generates more energy.
Thank you, sir. Thank you, sir.
Indeed, sir. Thank you. That was definitely a potential addresser. Even SP Singh sir is also agreeing in the chat box. You righteously indicated that our generation is being very careless towards the environment. We are also lagging behind in making our generation to understand the serious problem. But effort like yours, for example, that no tissue paper, recycling cloths, no new shadi ka lifafa are definitely changing the world. Or better, I should say, everyone who are present here, we all pledge to make such beneficial efforts to change our environment towards a better world. And we thank you for the entire address.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Now, to improve our program for the next time, I would like to post the feedback link in the chat box. I request each and everyone to please finish this feedback. The link would be open for the next half an hour for all of you to please finish this soon. And today, as we bid farewell to this FDP, let us carry all the lessons that we have learned and the experience we have gained as a constant source of inspiration. I would now like to request Dr. Anamika Srivastav to please present the formal vote of thanks for all of us.
Thank you, Dr. Juhi. A very good evening to all the respected dignitaries, scientists, academicians, and everyone present here today. I, on behalf of NRES domain, stand before you to extend my heartiest gratitude and deliver a vote of thanks at the valedictory session of the 5 days faculty development program on building a sustainable future with green technology, innovations, opportunities, and challenges, organized by MIT Academic Staff College in association with Natural Resource and Environmental Sciences domain. This gathering of brilliant minds and esteemed participants has truly been an enlightening experience, and I'm honored to have witnessed the wealth of knowledge shared during this event. At the outset, I, on behalf of NRES domain, would like to convey our deep regards and hearty thanks to our Honorable Founder President, Dr. Ashok Kumar Chauhan, sir, and Chancellor MIT University, Dr. Atul Chauhan, sir, for their continuous guidance and encouragement. It is their vision and leadership that has placed MIT University among the top universities in the world. I extend our sincere appreciation to Dr. Renu Thupar, Joint Coordinator, AIS, for delivering the warm welcome note, and Dr. Juhi Gupta, Assistant Professor, AIS, for sharing the highlights of the past 5 days. Your insights have beautifully summed up the event, and we are grateful for your valuable contribution. We would like to extend our deepest gratitude to Dr. SP Singh, Domain Head, NRES, and Director, ASNRSD and AIGIRS, for his encouraging word. Your expertise and guidance have been invaluable, and we are thankful for your presence here today, sir. Our heartfelt thanks goes to Professor Tanu Jindal, Group Additional Pro Vice Chancellor, R&D, MIT University, Uttar Pradesh, India, for sharing your valuable insights with us. We would like to express our sincere appreciation to Professor D.K. Bandyopadhyay, sir, Chief Advisor, FP, Founder President Office, Chairman of MIT Law School, and Mentor, MIT Institute of Environmental Sciences, for your enlightening address. Your expertise in the field has brought a unique perspective to our discussion, and we are truly grateful for your valuable contribution. Our heartfelt thanks goes to Professor Dr. Balwinder Shukla, Vice Chancellor of MIT University, Uttar Pradesh, in absentia, for her visionary leadership and commitment to academic excellence. She has been a guiding and motivational force for all of us. We would like to extend our sincere gratitude to Dr. Arvind Kumar, President and Founder, India Water Foundation, for joining us as our esteemed guest of honor. Your presence and knowledge you shared have truly enlightened us, and we are truly thankful for your contribution. Our heartfelt thank goes to our chief guest, Dr. Manoj Kumar Kataria, Advisor and Scientist G, Science and Engineering Research Council, for gracing us with your presence and sharing your valuable insights and sharing how small things can bring in big changes. I would like to express our deepest appreciation to our distinguished guests who've graced this platform. Your expertise, passion, and words have not only captivated our mind, but have also ignited a spark within each one of us. We are truly grateful for your exceptional contribution and meaningful impact that you have made today. I would also like to extend our sincere gratitude to all the attendees who have made this FDP 5 days faculty development program a resounding success. Your active participation, engaging discussion, and thought exchanges have created a vibrant atmosphere, fostering an environment of learning and collaboration. It is through your presence and collective enthusiasm that we have been able to create a truly memorable event. Our heartfelt appreciation goes out to the organizing committee who tirelessly and with all the efforts that they can put have planned this event, and from conceptualization to the event coordination and coordinating logistics, your dedication and commitment have been exemplary. Without your hard work and dedication, this gathering would not have been possible. Furthermore, I would like to express our gratitude to the support staff, volunteers, and technical team who have worked behind the scene to ensure smooth operation and provide assistance whenever needed. Your professionalism, efficiency, and friendly demeanor have played a vital role in creating a seamless experience for all the participants. In conclusion, I would like to once again extend my heartfelt thanks to each and everyone who have been here, and your presence and participation have been a big support for all of us. Together, we have made this event a resounding success, and I'm confident that the idea and connections formed here will continue to inspire and shape the future. Thank you all. We look forward to crossing paths once again in the future. Thank you so much. Over to you, Dr. Juhi.
Thank you, Dr. Namika. In fact, thanks to all the faculty members of Natural Resource and Environmental Science domain, faculty members and staff members for the successful completion of this 5 days faculty program, and also for the participants who come from the first day to all the 5 days are still here for all the lectures. So thanks to all the faculty members and all the participants, and special thanks to our mentor, because only because of our mentor, sir, we are able to execute all these faculty development programs. Thank you, sir, for your guidance and motivation. Thank you, sir.
Now, Renu.
Yes, sir.
I cannot stop myself.
Yes, sir.
When I came to know that you are running fever, and you have not only fever, but a typhoid fever, attacked by the typhus fever, typhus, bacteria. Even then, dedicatedly, committedly taking faculty members together and coordinating with the help of the faculty members, with the different speakers, I am really cannot stop myself but to appreciate your high level of commitment and dedications.
Thank you.
Keep it up. Keep it up.
Thank you so much. I thank all the people who are appreciating us in the chat box, and we would like to bring some even better events for you for the next time.
Amrina kahan gaya? Amrina? Where is Amrina?
Sir, examination is going on.
Acha, Amrina's exhibition duty. Take.
I would just like to make a final request. If
Dr. Juhi, sir, Amrina is preparing for the next FDP, that is a Guru Dakshita, sir. So this time I give this responsibility to new faculty, Dr. Juhi, and Guru Dakshita is taken by Dr. Amrina Siddharth. Thank you, Juhi, because you have done excellent work. Thank you. Thanks to all the faculty members. Thank you.
So, Juhi, first time you did it.
Yes.
And first time you made it a success. Great.
Yes, sir. And in fact, sir, she has applied a new technologies in her PPTs and presentation. Excellent work you have done, Juhi. Good.
Thank you, ma'am. Mentor, sir, can we close the session now?
Yeah, please.
Okay.
Thank you, sir. Thank you, IT team members. Thank you.